Tonight we're exploring a cosmic enigma with a title that says it all. The deeper we look, the stranger Three-Eye Atlas becomes. We'll sift through its bizarre path, puzzling brightness, and the big ideas this visitor forces us to reconsider about our own cosmic neighborhood. Imagine meeting a traveler who doesn't speak our language, doesn't follow our customs, and, most important, doesn't plan to stay. That's what astronomers felt when they first traced the path of Three-Eye Atlas across the sky. It wasn't just another cold wanderer from the outskirts of our own solar system. Its track refused to curl back toward the sun. It didn't belong to our celestial family at all. It cut through our neighborhood with the indifference of a long-haul passenger stepping onto a platform only long enough to switch trains. A visitor with no return ticket. At first it was only a whisper on a detector, faint, stubborn, almost shy. Observatories pinged each other, shared coordinates, and stacked images to tease a moving point of light out of the static. Night by night, the line of dots, each one a separate exposure, drew a path that refused to behave like the gentle ellipses we learn in school. Instead of tracing a loop that would bring it home, the curve splayed open like a door left ajar. That shape told a simple story with wild implications. Three-Eye Atlas is unbound. The sun can tug, but it cannot keep. If you could sketch the idea without any math, you'd draw a shallow U that never closes. Comets and asteroids born here swing around the sun and return sooner or later. This one will not. It arrives from far outside the playground and departs to even farther beyond, carrying with it the dust of places we've never seen. That one geometry, that open curve, is a passport stamp from the wider galaxy, a quiet declaration that we are dealing with something from another star. Everything about that changes how you look at it. A homegrown comet is like a local accent. You learn its rhythms over a lifetime. With Three-Eye Atlas, every flicker in brightness, every hint of a tail, every twitch in its apparent spin becomes a clue to alien conditions. Did it spend ages drifting between stars, sandblasted by radiation into a tough rind? Did it get ejected from a young, chaotic system where giant planets slung smaller bodies around like pebbles at a pond's edge? Was it fractured in some long-ago scuffle, leaving it irregular and fragile, ready to crumble when sunlight finally warmed it again? The speed alone is a telltale. Anything moving fast enough to ignore the sun's grip is already a little odd. Speed compresses time. It means our window to study is short, our questions many, and our answers likely to be incomplete. Imagine a parade car rolling past at a brisk clip while you try to read a handwritten note taped to the side. You squint, you snap a picture, you run after it for a block, but the car is gone. That's observing Three-Eye Atlas, a sprint by a small army of telescopes trying to stitch a story from a scattering of moments. We instinctively reach for familiar labels. Is it a comet, with ices that vaporize into a veil? Is it more like a rock, hard and reluctant to let go of anything? The truth may be both or neither, or something that doesn't fit cleanly into our tidy categories. When the sun warms unfamiliar ices, perhaps ones more volatile than the common stuff we know, activity can switch on and off like a temperamental machine. Brightness can surge, then stall. A tail can grow lopsided. Dust can behave in ways that make seasoned observers frown at their screens. That strangeness isn't a problem to fix, it's the signal we came for. Because it is unbound, the geometry of watching it is different too. A native comet might grace our skies for months, fading and brightening as it rounds the sun. Three-Eye Atlas offers a slanted flyby. Each night, it cuts a fresh line through a new star field. The background of constellations, the familiar wallpaper of the sky, slips behind it, and it's the motion against that wallpaper we measure with obsessive care. With every data point, we refine the path, tightening the uncertainty and confirming what the first fits dared to suggest. This object is from away. There's a kind of intimacy to these pursuits. Teams in the pre-dawn hours pass the baton to teams at dusk across the ocean. Someone inhales cold air on a mountaintop, while someone else sips coffee in a cramped control room. Images arrive in bursts, and the faint dot is there again, right where the prediction said it would be. A tiny affirmation that the universe is legible. Yet that same dot refuses to be entirely known. Its exact shape hides inside the way its light waxes and wanes as it rotates. Is it spinning smoothly like a skater or tumbling like a tossed shoe? The answer alters how we think about its past, about collisions survived, about internal strength, about whether it's a monolith or a rubble pile held together by the gentlest of embraces. Call it cosmic anthropology. We cannot visit 3i Atlas, so we infer its culture from the artifacts it drops. A spectrum smudged with hints of unfamiliar ices, a light curve that stutters, a tail that bends in subtle defiance of the solar wind's expected push. Each oddity is a breadcrumb that points back to the system that made it. Maybe it formed beyond the frost line of some distant sun, among slow-growing grains and shy shadows. Maybe a migrating giant planet flung it outward with an angry swipe. Maybe it drifted in a local interstellar cloud, rich in molecules we only see in laboratories, picking up a skin of chemistry that now peels away in the warmth. There is also the question of age, not in years on a calendar, but in miles of story. Objects like this can wander for eons. The light that bounces off it today may carry the wear of journeys begun before our ancestors learned to shape metal. Think about that when you imagine the first photons from 3i Atlas finding their way into our cameras. In those photons are a million quiet insults from cosmic rays, a billion tiny collisions with dust, the slow rounding of edges and the deepening of cracks. We are not just watching a rock, we are reading a travel diary written in scars. And yet, despite the distance and the speed, 3i Atlas is oddly personal. It reminds us that our solar system is not a sealed room, but a house with doors and windows open to the street. Things come and go. Some visitors greet us politely, leave a calling card, and move on. Others pass without a word. This one did us the courtesy of being just bright enough, just close enough, just strange enough to be noticed. It asked us to drop what we were doing and pay attention. Paying attention is how we learn. When the data resist a tidy explanation, we don't despair. We sharpen our tools. We build better surveys to catch the next unbound traveller earlier, to map its path with more precision, to sample its light with more colour and depth. We practice agreeing on names and sharing raw images and releasing results fast enough that the whole world can help. 3i Atlas is not only a mystery, it's a rehearsal for the mysteries to come. If you want a simple phrase for what makes it special, here it is. It doesn't belong to us. It doesn't orbit our sun. It isn't part of our long-running family drama of planets and debris. It is the outside world walking through our kitchen, leaving a footprint on the tile and disappearing out the back door. That difference shifts the stakes. Instead of learning about how our own system works, we get a peek at how planetary systems work, plural. We glimpse variety. We taste the average, the rare, the unexpected. Each interstellar passerby is a sample from a different recipe book, and together they will tell us which ingredients are common, which are special, and which are pure surprise. So we follow. We trace, measure, and model, knowing the clock is always against us. We accept that certainty will remain just out of reach, that our best stories will need footnotes and the word perhaps. But even with those caveats, the fact remains. 3i Atlas is a messenger from beyond our borders. A traveller with no return ticket forces us to think bigger than our backyard. It nudges us toward humility, toward patience, and toward a deeper curiosity about what else is out there, moving fast, unbound, and briefly, beautifully, within view. It began the way many discoveries do, quietly, almost rudely small against a huge sky. The survey dome yawned open, motors hummed, and a wide-field camera started its nightly sweep, tile by tile, like a librarian checking shelves by touch. On the screen, the stars behave themselves. They always do. They sit still, patient as pins. The trick is to find the thing that refuses to sit. A stack of fresh frames landed in the pipeline. The software did its routine. Subtract last night from tonight, smooth the noise, flag anything that moved or flared. Most of what it finds is junk, hot pixels, the brief scratch of a cosmic ray, a satellite grazing the field like a streak of chalk. One candidate pinged with low confidence. Then another frame of the same patch came in and nudged that confidence up. A technician leaned closer, not because the display was dim, but because habit teaches you to meet the sky halfway. Click, click, click. The images blinked back and forth, the old-school method dressed in modern code. The stars stayed put. One faint dot hopped, just a little, to the side where no star should hop. Suspicion is the default in a survey control room. The team tried to kill it. They checked for artifacts. Was there a faint scratch of satellite light just outside the frame? A glint off a lens element? They rotated the image, reran the subtraction with a different threshold, and tried a separate detection algorithm that liked to disagree with the first one. The hop survived all of it. It was small and strangely steady. Not a flare, not a bug, a moving point. The clock had slipped past midnight. Somewhere, a coffee machine hissed and a status board muttered out exposure times like a metronome. A second telescope, smaller, faster to pivot, was nudged toward the candidate. In the time it took to collect a fresh trio of frames, a few messages were already riding the usual channels: coordinates, an early estimate for the track across the stars, a polite "if you're awake" to colleagues in a friendlier time zone. The small telescope returned its verdict: the same hop, the same direction, the same stubborn persistence against the fixed wallpaper of the sky. Once you have a handful of positions, you can begin to tell a story about a path. The path doesn't need numbers to be meaningful. You can sketch it in your mind, a slender line drawn across a grid of constellations, arcing not like a loop, but like a visitor crossing a room on the way to another door. The first fits were crude, and they wore their uncertainty openly, but they whispered the same thing. If this keeps up, it's not one of ours. No one says that out loud at first. You ask simpler questions. How faint is it? Can we see any smear of a tail, any hint of fuzz beyond a star-like point? Are there older images, those sleepy archived frames from weeks or months ago, where it might have passed unnoticed? The hunt for pre-coveries began immediately. That meant trawling through fields where the new path said it might have been. Sometimes you find only darkness and noise. Sometimes you find a ghost that was always there, waiting to be recognized. Clouds drifted across one site and handed the baton to another far away. Astronomers on a mountaintop switched the filter, then switched back when the signal sagged. An observer in a control room talked quietly into the room mic, calling out times and estimated positions. A calm voice dragged forward by adrenaline. The dot arrived where predicted. A small triumph folded into the mechanics of following it. The positions, each one a tiny vote, started to add up. When a new object appears, the first instinct is to sort it into a bin. Near Earth, main belt, distant, cometary. The bins are helpful because they let the world coordinate quickly. But 3i Atlas refused easy filing. Its brightness flickered a little night to night, as though some part of it had begun to wake under the sun and then reconsidered. It had the clean, star-like look of an asteroid in one exposure, then the halo, soft look of a small comet in another. The line it traced against the constellations lengthened, and those crude fits began to look less crude. The open curve story got louder. You can feel the mood change when a candidate crosses that invisible line between probably nothing and this could be something. The chatter gets tighter, the language shorter, the jokes drier. A coordinator pushed out a formal alert to the wider observing community. New transient, motion confirmed, follow-up requested. Telescopes that were about to tuck in for the night yawned again and took a look. Larger mirrors found it easily. A few amateurs with sharp equipment and sharper patience picked it up too, their images joining the stream like honest witnesses. Someone tried a spectrum, light split into its quiet barcode, hoping for a clear whisper of familiar ices. The signal was almost too thin to use, a spiderweb pulled tight. Even so, there were hints, and hints were enough to keep the list of questions growing. If this really was what the path suggested, it hadn't been living in our deep freeze for long. It didn't know our sun. It was reacting like a traveller stepping into a climate they didn't pack for. Dawn came rudely to one hemisphere, and night obliged the other. The dot had marched onward, past one constellation boundary and into another. The path drawn by last night's positions overlapped almost perfectly with tonight's. The fit tightened like a knot. On a whiteboard, someone sketched the difference between a loop and a not loop, smiling at the simplicity of it, even as the data underneath grew complicated. The notion that this visitor would not circle back ceased to be an idea and started to feel like a fact you could trust. Even the way it moved felt different. A local comet often dramatizes its visit, a long swoop in, a swoop out, brightening and fading as it leans into and away from the sun. 3i Atlas behaved like a through line. There was less theatre and more intent, a steady crossing that made the night feel short by comparison. That steadiness, curiously, made people more alert. It said, "You won't get another pass at this." Phones buzzed on nightstands in cities far from any observatory. People who had told themselves they'd sleep through tonight didn't. You don't want to be the last person to hear the song everyone is humming. A senior observer pulled up the running list of positions and checked the residuals, the measure of how well the story you're telling matches the real sky. They were small, smaller than they had a right to be this early. That's when the cautious smiles finally broke. The naming talk is always gentler than you'd expect. Names are labels, and labels are stories. The team wasn't thinking about headlines. They were thinking about how the label would carry the memory of this night forward, so that anyone who glanced at a future plot or catalogue entry would feel a little echo of it. When 3i Atlas became the way to say it, it wasn't an argument. It was a nod. The syllables carried the work of countless frames, the chill of dome air before sunrise, the collective willingness to be surprised. As the night wore on, a few stronger images revealed a hint of structure, a whisper of fuzz around the point, then a breath of tail. It wasn't dramatic, but just as a single leaf can tell you there's a tree behind a wall. That breath was enough to change what people looked for in the next data. They tuned their exposures, adjusted their tracking rates, and started to listen for the faint sighs of activity that might rise and fall in fits. Confirmation isn't a single moment, it's a braid. The braid that night was made of checklists and human judgment. The way the object kept its appointment with each new field. The way the brightness refused to settle into a neat pattern. The way the path held open like a door you can see through. Every new measurement tightened the braid, and each tug on it pulled more eyes into the room. By the time the first birds were thinking about singing outside one observatory, the global relay was already in play. Western mountains handed it to islands in the ocean, who handed it to southern skies, who nudged it across to deserts with dry air and steady seeing. The dot did not care who watched it. But the act of being watched, noticed, measured, coaxed into a first sketch of identity, turned that indifferent speck into a character in a shared story. In the end, the night did what nights do. It yielded to morning, and the data yielded to a first draft of an understanding. No fanfare, just a handful of images and numbers that meant more than they looked. A traveller had blinked into view. It didn't follow our rules. It wasn't one of ours. And from that small, stubborn set of facts, 1,000 new questions woke up and stretched. Names are more than labels. They are the first story we tell about a thing. Long before most people ever see an image, a name is what travels between observatories, inboxes, newsrooms, dinner tables. It's the handle we grab when the object itself is too far, too faint, or too fast to hold. That's why the way we say 3i Atlas matters. It's a small spell we cast on ourselves every time we speak it. A set of expectations smuggled into a few simple words. Start with the 3. Count words can feel dry on paper, but in space they carry context. 3 says this is not a one-off or a fluke. It's the next entry in a growing family album of visitors from beyond the sun's rule. First we met one stranger, then another, and now a third. With that single syllable you can hear a category forming, a pattern asserting itself. 3 invites comparisons. How does this traveller echo and contradict the first 2? It quietly tells the community to get out the checklists. What changed? What repeated? What defied both expectation and precedent? In science, the third instance often marks a turn from curiosity to confidence. 1 can be an accident, 2 can be a coincidence. 3 starts to sound like nature clearing its throat and saying, pay attention. Then there's I. At first blush it feels playful, almost human, in a field that often hides behind acronyms and catalogue numbers. I is what you notice in a face. It's how we meet one another. The word pulls this distant speck a few steps closer to us. It also winks at the way we discover things. Arrays and mirrors acting as planet-sized pupils, blinking open at dusk to drink starlight. But tucked inside the word is another resonance you can't quite ignore. The cultural whisper of a third eye, the sense of perception beyond the ordinary. No mysticism required to feel it. The phrase simply nudges the imagination. An object from interstellar space is already an outsider. Attaching an eye to it suggests a watcher as much as a thing watched, a mirror held up to our habits of seeing. Say I, and you remember that discovery is as much about the instrument and the gaze as it is about the target. Finally, Atlas. The word sits on 2 legs at once. On one side is the mythic figure bearing the heavens, a timeless image of endurance and scope. On the other is the practical book of maps, the thing you unfold when you want to turn the unknown into a route. The sky survey that first raised the alarm borrows this name for a reason. Night after night it holds the weight of the sky across its cameras, compiling page after page of celestial changes so that outliers don't slip by. To speak Atlas is to acknowledge the infrastructure of attention, the domes, the schedules, the calibration stars, the quiet collaboration across continents that makes a discovery like this possible. It's not only a name, it's a thank you to the machinery and the people who keep it humming. Put the 3 pieces together and you get a phrase that works on the tongue and in the mind. 3i Atlas. The cadence lands cleanly in a voiceover, it prints neatly in a headline, and it's memorable enough to cross languages without turning into alphabet soup. It avoids the clinical chill of pure code while keeping a backbone of meaning you can unpack. 3 binds it to a timeline. I makes it feel alive in our noticing. Atlas ties it back to the map makers who caught it, and to the myth that says the sky is heavy and worth carrying. This matters because names guide behaviour. When a new object appears, hundreds of small decisions cascade through the system. Do we spend precious minutes of telescope time on it tonight, or wait a week? Which filters do we use? Who should we ping for spectra? What do we tell the public? A crisp, intelligible name becomes a rallying point. It compresses the pitch. It lets a tired observer glance at a schedule and instantly recognize the thing that needs one more look before dawn. It gives a journalist a word they can read aloud without tripping. It gives students something they can search for and find, a doorway into the deeper technical details. Names also shape the frame of the questions we ask. Call something a comet, and you start looking for a tail. Call it an asteroid, and you picture a dry rock. 3i Atlas refuses to push us into either corner too hard. It arrives as a sentence more than a tag, a small poem that keeps pathways open. The I in the middle softens the category walls, reminding us to observe first, label second, and be ready to change our minds if the light behaves strangely. That gentle agnosticism is precious. It keeps the science honest while the data are still thin. There's another, quieter way the name works. It invites ownership by everyone. Catalogue designations can feel like passwords you forgot. 3i Atlas feels speakable. You could tell a child about it, and they could say it back. A teacher could write it on a blackboard, and students would feel like they met something, not just read a code. That shared ease is how a discovery leaves the lab and enters culture. A decade from now, someone might remember where they were when they first heard the phrase, the same way people remember a storm's name or a comet from their childhood. That's not fluff. It's how curiosity sustains itself across years, budgets, and generations. If you listen closely, the name is also a bridge between scales. 3 is a tiny count word. It fits in your palm. I is intimate. It belongs to a face, a gaze, a person. Atlas is vast. It stretches across continents and myths. In one breath, you move from the smallest unit of number to the human act of seeing, to the sweep of the sky itself. That transit, the leap from the personal to the cosmic, is exactly what an interstellar visitor asks of us. The name rehearses the journey our minds will take as we learn more. Start with a count, notice with care, then map what you find into the largest picture you can hold. It's worth noticing how the name behaves when you speak it quickly in the middle of a long night. It doesn't snag. It doesn't require a pause to decode. In the control room, friction matters. The fewer mental steps between a thing and the word for that thing, the easier it is to coordinate, to log, to make decisions. 3i Atlas carries its own explanation without stopping the flow. Even its rhythm, 3 soft beats, matches the tempo of status calls and timestamps. These are small details, but small details are the gears in large machines. Of course, every name is a compromise between poetry and procedure. There are formal conventions in the background, systems that ensure the record is accurate, searchable, and consistent across decades of observations. Yet the public face of a name can still hold a spark. 3i Atlas strikes that balance. The formal lineage is preserved elsewhere. Here, in ordinary speech, we get something we can remember and pass on without losing the essence. Names can also be a hedge against our own biases. When we give something a dramatic title, we risk seeing only drama. When we give it a sterile code, we risk forgetting why we cared. 3i Atlas sits in the middle, a calm reminder that the extraordinary can be approached with steady human attention. It says, "This is the third time the galaxy has sent us a traveller we can measure close up. Open your eyes, consult your maps." And yes, the echo with third eye lingers whether you invite it or not. For some people, it will be a playful coincidence. For others, a meaningful symbol. Either way, the tag produces an emotional readiness to look deeper than the surface, a stance that science, at its best, rewards. No rituals required, just the habit of peering past first impressions. Does the light curve tell a simple spin or a tumble? Is the glow uniform or patchy? Are we seeing familiar ices waking up, or something less common flickering in and out? A name that nudges us toward careful seeing earns its keep. Think too about endurance. Long after the object has cut its line through our sky and gone on, the name will remain pinned to tables, figures, and plots. Future students will stumble onto it in a database and click. A researcher chasing a pattern across multiple interstellar visitors will stack file names like stones, and there it will be again. 3i Atlas, another piece in the mosaic. The way a name reads years later matters because it determines whether the object stays in active memory or fades into a fog of codes. This one feels like it will hold. In a way, the name performs the exact work of a good map. It reduces the distance between unfamiliar and known. When you first hear interstellar object, the phrase can feel abstract, a little cold around the edges. Say 3i Atlas instead, and you get a path through the abstraction. Third in line, seen by human eyes, caught by a global atlas of sky watchers. The distance shortens. The thing becomes, if not familiar, then at least approachable. So when we insist on saying it this way, 3i Atlas, we're not just being picky about pronunciation. We're choosing the story that will travel with the object as surely as its photons do. We're deciding to remember that it belongs both to a growing set of interstellar messengers and to the act of looking that brought it into our awareness. We're honouring the shoulders that carried the sky long enough for us to notice one flicker in it, and we're giving ourselves a phrase sturdy enough to carry forward long after the visitor itself has slipped back into the wider dark. Picture the solar system as a vast skating rink. Most of the skaters, planets, asteroids, comets, trace graceful loops around the centre, pulled inward by the sun's steady grip, but balanced by their sideways motion. Those loops are family behaviour. You can predict where the skaters will be next season because they always come back to the same part of the rink, again and again. Now imagine a stranger gliding in from the dark edge, not circling, not rehearsing the family routine, just crossing the rink in a long, unwavering arc and slipping out the far door. That is the path of 3i Atlas, a path that won't close. You don't have to draw math to feel what that means. A closed path is simply a promise, full toward the sun, curve and return. An open path is the refusal of that promise. It is motion with no intention to stay. Observers learn this by the oldest method in the book. Mark where the point of light is, wait, mark again, and keep doing that until the marks trace a story. At first the story is smudged. The dots could belong to several different plots. But as nights pass and the line of dots stretches out, the plot sharpens. A loop begins to look like a loop. An escape begins to look like an escape. With 3i Atlas, the line kept opening like the jaws of a key ring. The more dots you added, the more certain you became that no amount of tug from the sun would fold it back. A good way to picture the why is with a funnel and a marble. Drop the marble gently and it spirals inward round and round. That's a closed path. Flick it harder and it swoops in, turns and rockets out. That's an open one. The difference is not mystical. It's about having more than enough speed to ignore the well once you've skimmed its lip. 3i Atlas arrived with that more than enough baked in. The sun pulled and the path bent, as all paths do under gravity, but not nearly enough to turn the ark into a loop. Think of it like driving through a valley. The car dips, the road curves, but if you keep your foot on the gas, you crest the opposite hill and keep going. You don't roll back into the valley unless you slow down or hit the brakes. There are no brakes in space. The way the path refuses to close shows up in small, practical ways that observers talk about when the dome is still cold. Predictions for tomorrow's position stop looking like the usual family curves and start looking like a clean sweep across constellations. Instead of a route that turns back toward the sun's glow, the projection line cuts forward day after day, stealing a little altitude above the plane where most planets reside. When the path won't close, you plan differently. You schedule telescopes earlier than you'd prefer. You accept lower elevations or thin clouds because the window is short and shrinking. Every night missed is a piece of the path you will never recover. There's a peculiar beauty in the single pass. A local comet may preen for months, growing and fading, rounding the corner and drifting home. 3i Atlas performs a different theatre. It has a one-act arc. The entrance is from the wings beyond our lights, the stage crossing is brisk, the exit is decisive. No encores. That alone reshapes the questions you ask. Of a returning object you might ask, what will we learn next time? Of 3i Atlas you ask instead, what can we wring from the few nights we are given? Even so, open paths are not straight lines. Gravity is everywhere, playing the quiet hand. As 3i Atlas dives toward its closest approach to the sun, the arc tightens a little. As it climbs away, the arc relaxes. Seen against the fixed wallpaper of stars, the movement speeds up near the low point and slows as it recedes. A graceful speed up and slow down that every planet and comet shares. The difference here is the way the before and after refuse to mirror a loop. We will never get the after that returns to before. The second half of the path is not a repeat, it's a farewell. It helps to imagine the solar system's plane as a wide river where most of the traffic flows the same way. 3i Atlas doesn't drift with that current. It cuts across at an angle, a diagonal canoe slicing through barge lanes. That tilt is part of the outsider's signature. It tells you the object wasn't born from the same flat, swirling disk that made our worlds. It learned its habits elsewhere, under a different geometry, in a different neighbourhood of planetary construction. The angle is a clue you can see in the sky's changing backdrop, as the dot of 3i Atlas slides not just forward, but above or below the familiar river of planets. As the path reveals itself, small forces whisper along its edges. Sunlight pushes on dust-sized particles like a breeze across dandelion seeds, and if the object is shedding anything at all, that breeze can wiggle the apparent track of the cloud around it. Jets of gas turning on and off, tiny intermittent thrusters powered by thawing ices, can nudge the central body one way or another. With many comets, those nudges, though slight, add up. For 3i Atlas, even with such gentle pushes, the core story doesn't change. The arc remains open. You can warp a path a little with weather, but weather can't turn an exit into a homecoming. People sometimes ask whether a heavy planet might step in and change the ending, Jupiter especially, with its deep well and habit of bossing small bodies around. It's a fair question. A close brush with a giant can reshape a traveller's destiny, sometimes dramatically. But close in space is not what it sounds like on Earth. Most of the time the distances and relative angles are wrong for capture, and a fast traveller is hardest of all to catch. For 3i Atlas, the geometry we reconstruct from our night-by-night dots says the big players will tug yes. but there is no meeting arranged tight enough to steal the visitor's freedom. The leash never clips. The phrase, "won't close," also speaks to our certainty. When an object is new, uncertainty balloons around the plotted points, like soft halos. If those halos overlap both family loop and escape arc, you keep your mind open. But as data arrive from more nights, more hemispheres, more instruments, those halos shrink. They stop touching the loop. With 3i Atlas, that shrinking happened steadily, and frankly faster than many expected. The path stood up under scrutiny. No reasonable way of bending the errors turned it into something bound. You could feel the room relax into that fact, not with relief exactly, but with a clear sense of the problem now framed. We have one chance to study a passerby. Once you accept the open path, the whole observing campaign pivots to serve it. You choreograph a relay across longitudes so there are fewer gaps. You widen the net of filters to catch as many behavioural hints as you can while it's bright enough. You adjust tracking rates because a fast, unbound object doesn't drift like a familiar comet. It marches. Exposure times too are tuned so the point doesn't smear into a streak before enough photons land on the detector to mean something. Everything becomes a conversation between speed, faintness, and the precious supply of dark hours left. Even the language in logs changes. For a bound body, you might jot "next return," "next apparition." We'll revisit this geometry in X years. For 3i Atlas, you write dates with an almost ceremonial precision. The night of first clean detection. The night the path's openness crossed all reasonable doubt. The date of closest approach to the sun. The last night a mid-sized telescope could still pick it out before it faded into noise. These become anniversaries for people who live by the calendar of the sky. The path that won't close leaves behind a sequence of nights that will never repeat. There's a deeper consequence to an open path that goes beyond logistics. It changes the kind of knowledge you expect to harvest. Closed paths invite patience. You can refine models across multiple cycles, watching how seasons on a comet evolve, how jets carve features, how dust trails accumulate. Open paths demand synthesis. You thread everything you learn: motion, brightness, colour, shape hints, any whiff of unusual gas, into a single coherent portrait, however provisional. The portrait will be the record. Years from now, when someone asks what we knew of 3i Atlas, they will turn to this portrait and to the surety that its path was a crossing, not a circle. And yes, there's an emotional undertow in all this. A loop feels like comfort. It promises return. An open curve feels like truth. It promises honesty about the scale we live in. Our star is mighty up close, but the galaxy is full of travellers that carry momentum from other stories, other suns. 3i Atlas is one of them. Its refusal to close is not a snub. It's a message written in motion. There are other centres, other families, other floors to the cosmic house. Watch any long enough sequence of images and you'll notice one more thing. The path that won't close is oddly clarifying. It draws a line across the sky that teaches you the shape of your own neighbourhood by contrast. As 3i Atlas passes, planets drift by with their familiar stateliness. Asteroid families keep their quiet lanes. Distant comets pace their slow arcs. Against that order, the traveller's diagonal sings. You realise how much of our understanding depends on those who do not belong, staying just long enough for us to measure the difference. So the path of 3i Atlas is not only an astronomical fact, it's a narrative structure. Entrance, turn, exit. The turn near the sun is the breath we hold. Before it, we anticipate. After it, we reflect. In between, the object's behavior is written into a curve that our instruments can read without recourse to difficult symbols. The shape says everything we need. There will be no second lap, no next season, no familiar return arc traced against winter stars. There is only this crossing, and that is enough. If you've ever tried to take the pulse of a wild animal, you know it never sits still long enough for an easy reading. That's what measuring the brightness of 3i Atlas feels like. A living heartbeat that refuses to keep the same rhythm twice. Night after night, observers aim their mirrors, collect photons, and line them up in time to make a simple graph, brightness on one axis, time on the other. For many comets and asteroids, that graph settles into a reassuring up-down pattern. Spin gives you a drumbeat. Distance from the sun gives you a slow swell or fade. With 3i Atlas, the line jitters, stalls, leaps, and sometimes hums two tunes at once. Start with the most innocent explanation: geometry. The universe can change the look of a thing without the thing changing at all. As 3i Atlas slides through the sunlight, the angle between sun, object, and Earth keeps shifting. Turn a coin under a lamp and you'll see it. Sometimes you get the shiny flash straight back into your eye. Sometimes the coin looks dull. Dust around a comet acts like 1 billion tiny coins. At certain angles, the dust doesn't just reflect, it glows as though the light is passing through and scattering forward, giving a sudden, unearned brightness. A small change in angle can look like a mood swing. To a tired observer at 3 in the morning, the curve jumps and you can almost hear it say, "Catch me if you can." But geometry alone can't explain the texture of the flickers. There's personality in them. Imagine 3i Atlas as a lumpy, rotating body, one side darker, the other side lighter, with cliffs, craters, and dusty ledges. As it turns, the bright side faces us and we get a lift. The dark side rolls into view and the light dips. If the shape is stretched, more potato than sphere, the highs and lows sharpen. If the spin is tidy, the pattern repeats cleanly and you can tap your finger to it. If the spin is messy, tumbling rather than turning on one neat axis, the pattern frays. You hear overlapping rhythms, a quick beat laid over a slower one, sometimes adding together into a surge, sometimes cancelling into a lull. The graph starts to look like a conversation rather than a metronome. Then there's the matter of breathing. A visitor warmed by sunlight does not wake up gently. Patches of ice face dawn and exhale. Jets switch on like sprinkler heads, then fall silent when the angle changes or a local supply runs thin. Think of little factories on the surface, each with its own schedule, its own plumbing quirks. One jet might point into the night side for hours, doing nothing you can see. Then, as the body rotates, it swings into daylight, and suddenly that factory roars to life, dragging dust with it. The brightness spikes. A few hours later, a second factory takes its turn. The spike becomes a plateau. The plateau fractures into steps. You can trace these shifts in the curve, but you can't predict them far ahead. Not without knowing the shape of the land, the thickness of the crust, the mix of ices. Details the universe keeps close. Sometimes the curve doesn't climb or fall so much as stutter. That can be the sign of something more dramatic, a crust that can't handle the stress. Picture a brittle ledge under morning heat, cracking and sloughing off into space. A puff of debris turns the comet's faint halo into a thicker veil, and your graph jumps like a needle catching on a groove. Hours later, the extra dust drifts and thins, the gravity of sunlight itself pushing the smallest grains away, and the graph slides back toward where it was. The event leaves a scar you can't see in a single picture, but you can feel in the timeline, the way a voice trembles after a shout. Observers are careful creatures, so they spend a lot of time asking whether the mischief is in the sky or in their own machines. Thin cloud can imitate a dip. The moon can lay a film of extra light over the field, making a faint object look flatter than it is. Different filters, slightly different focus, the way a telescope tracks a fast-moving target. Each change can sneak into the numbers. That's why the story only really hardens when separate teams with separate gear report the same whispers on different nights. When a dip shows up in Chile and again in Spain, when a surge appears in Hawaii and then echoes in South Africa, you stop blaming weather and start listening to the traveller. There's a craft to measuring the brightness of something wearing a veil. You can measure the central point alone, trying to hear the voice of the solid core. Or you can include more of the surrounding haze, which is where the drama often lives. Choose a small measuring circle and you get a view that's touchy but quick to react. Choose a larger one and you smooth the curve, but risk blending distinct events together. Observers try both. They test how the curve changes when they widen the circle, the way a chef tastes a sauce again after adding water. If the core brightens while the halo stays steady, that smells like rotation with patchy sunlight. If the halo brightens while the core hardly changes, that smells like a jet turning on, or a small outburst adding fresh dust. Colour adds another thread to the braid. When 3i Atlas brightens, is the light shifting toward the blue end, hinting at fresh gas, or toward the red, hinting at more dust? A rise that is bluer could mean new ices are vaporizing, a neat chemistry flourish. A rise that is redder could be the sign of dust grains taking over the stage. A few nights of well-timed colour checks can tell you whether a spike is made of breath or of grit. With this object, the answer refuses to settle. On one night, a swift lift looks like gas. On another, a slower swell bears the signature of dust. The curve won't sit still, and neither will its wardrobe. As 3i Atlas approaches the sun and then sweeps past, the rhythm itself can change. Spin can speed up or slow down under the touch of sunlight, the way a garden sprinkler will twitch if one nozzle sprays harder than another. Over days or weeks, the period of the up-down pattern can drift, and because Earth keeps turning and giving us nightly gaps, those drifts can trick the ear. What looks like one beat may split into two. What sounded like two may resolve into one. Teams compare notes, align their clocks as best they can, and build a composite curve that stretches across longitudes. Stitching those pieces together is part art, part patience, and part luck. Every so often, the curve does something rude. It plateaus at a slightly higher level and refuses to come back down. That could be a sign that the traveller has shed a fragment, a small piece, too faint to separate in the image but bright enough to contribute a steady glow. Or it could mean a new region on the surface has been permanently activated, a door jammed open by heat. In both cases, the story is less about weather and more about change. The object you measured last week is not quite the object you're measuring tonight. There's also a subtle game the universe plays with distance. As 3i Atlas nears the sun, you expect a general brightening. As it recedes, a general fade. Lay that slow swell under the quick up and down of rotation and jetting, and you get interference, beats and patterns that feel like two melodies arguing. If you try to remove the slow swell to study the fast flicker, you might remove too much and flatten the truth. If you ignore it, you might mistake the tide for a storm. This is where experience helps. People who have watched many travellers learn to separate tide from weather by feel, checking their instincts against nights when conditions are perfect and the curve reveals its backbone. Dust does not just brighten, it shapes. Big grains hang near the traveller longer, fine grains drift and spread. If a burst favours one size over another, the curve's rise and fall will have a particular slope, a particular tail. Observers learn to read those slopes the way a tracker reads footprints. A steep jump and a quick slide could mean fine powder washed into space and faded under sunlight's shove. A slower ramp and a lingering high could mean heavier grains that stick around, thickening the veil for a while before thinning. 3i Atlas writes both kinds of signatures, sometimes in the space of a single night. And hanging above all of this is the question everyone wants answered. How much of the curve is the solid heart, and how much is the hazy breath? If you could turn off the activity and see only the core, you'd learn its size, its true reflectivity, and how fast it turns. But the object will not oblige. So observers invent clever tricks, watching when the veil is thinnest, catching the traveller at angles where dust contributes least, comparing different bands of light to tease the core's voice from the chorus. The result is not a single number, but a range, a family of plausible selves that the data will allow. It's not indecision, it's honest reporting when a thing refuses to stand still for a portrait. None of this chaos is a failure, it's the point. A quiet, obedient light curve would have been a comfort and a missed opportunity. The restlessness of 3i Atlas tells us about its shape, its skin, its plumbing, its daily weather, its mood under heat, and even the way sunlight can torque a body over time. It asks more of us: faster coordination, more careful calibration, patience with false leads, and pays us back with a closer look at how an interstellar stranger behaves when it passes through our light. By the time the traveller fades beyond the reach of medium mirrors, the graph on the wall will look like the scribbles of a polygraph. Jumps, plateaus, sawtooth climbs, soft humps, clipped peaks. To someone outside the room, it might look like noise. To the people who chased it across nights and oceans, it will read like a diary. Here is where the first jet woke. Here is where the angle made the dust sing. Here is where something cracked. Here is where the rotation learned a new step. And here, this restless line that never quite repeats, is where 3i Atlas reminded us that light, when watched closely, is never just light. It is behaviour written in brightness, a moving story you can see. Imagine tossing a book into the air with a crooked throw. It doesn't spin like a ballerina on a turntable. It wobbles, flips and precesses, showing a new face every heartbeat. That is the feeling many observers get when they watch the light from 3i Atlas rise and fall. There are nights when the rhythm suggests a neat twirl, peaks and dips spaced almost politely, followed by nights when the pattern frays, as if a hidden wobble has joined the dance. The difference matters. A clean spin hints at a body holding itself together with confidence. A tumble hints at history, knocks survived, jets that push unevenly, or a shape so lopsided that steadiness is a dream it never quite reaches. Start with the quietest possibility, a simple rotation, like a slow baton turning in the dark. If 3i Atlas were compact and roughly rounded, the brightness might only breathe with distance from the sun, but give it an elongated outline, more canoe than ball, and you get a repeated signal as the long side and short side alternately face us. The light spikes when the broadest cross-section turns our way, and softens when we're staring at the skinny edge. If that were the whole story, we'd measure a tidy period and move on. Instead, the curve sometimes duplicates beats, then slips by a fraction, then doubles back, a stutter step that makes careful people squint. That is the first whisper that something more complicated is happening than a single smooth turn. A tumble is not chaos for chaos's sake, it is a symptom. Picture 3i Atlas as a lumpy, stiff object whose mass isn't spread evenly. Give it one good shove, maybe a small impact ages ago, maybe a jet that ran longer on one side than the other, and the object will begin to rotate not just around one favoured axis, but around several at once. The result is a layered motion, a slow wobble that tips the main axis around like a wobbling top, with a faster spin nested inside it. To our eyes, that layered motion looks like a light curve that is almost repetitive, almost periodic. And then, at awkward intervals, not quite. You think you've learned the beat, only to find there were two beats hiding in the same song, drifting in and out of sync as the nights go by. Sunlight itself can stir the pot. When fresh jets turn on, they act like tiny misaligned thrusters, puffing more in one direction than another. If a jet is placed just right, it can steal or donate spin, the way a gardener's sprinkler will twist if one nozzle sprays harder than the rest. Over days to weeks, such uneven breath can speed the rotation up, slow it down, or tilt the preferred axis, changing the choreography mid-performance. That is why observers trade notes with unusual urgency when a sequence shows the period creeping. The object is not a clock, it is a windmill in a shifting breeze, and the breeze is made of its own outgassing. Shape is the co-conspirator in every spinning story. A single block spins one way, a dumbbell spins another, a contact pair, two lobes touching like a snowman, adds tricks of its own. If 3i Atlas is bilobed, as many cold bodies are, then the light can rise not once but twice each turn, each lobe offering a bright side and a dark side of its own. If the neck between lobes vents gas, the neck can act like a hinge with a rocket strapped to it, changing not only how fast the whole thing turns, but how the lobes tug against one another. Spend enough nights with the data, and you begin to suspect a silhouette, perhaps a stretched core with flats and cliffs, perhaps two pieces held together by touch and luck, perhaps a more ragged, gravelly cluster where the word surface is more suggestion than fact. There is an unromantic physical limit hiding under all this poetry. Hold a spinning stone by a string and swing it faster and faster, and sooner or later the string will snap. In space, the string is the feeble grip of gravity and the subtle stickiness of grains pressed together. If 3i Atlas is a loose pile, a rubble heap drawn into a single object by the gentlest embrace, then a rising spin can pry at its seams. The first signs are rarely theatrical. A bit of dust refuses to settle back. A shard drifts away and then fades. Your measurements don't shout, they tilt. The baseline brightness sits a little higher and never quite returns to where it was. The light curve that once had crisp peaks starts to broaden, as if the object's outline grew fuzzier. You think about separation, not with drama, but with the weariness of someone who has seen a bolt back itself out of wood. Now imagine the very local weather. Morning on one face, night on the opposite. As 3i Atlas rotates, patches of volatile ices cycle in and out of sunshine. Some patches vent with gusto, others, shielded by crust or shadow, wait their turn. This patchwork turns the object into an irregular engine. When a jet erupts near a ridge, the exhaust doesn't point into empty space. It ricochets, drags dust along contours, and pushes on the body at off-center angles. Even a small, persistent push at a slightly wrong place, repeated thousands of turns, can tip a spin from neatness into a wobble. Out there, nothing is bolted to a frame. Every push counts. Because Earth spins and weather happens, we rarely get to watch the whole dance in a single sitting. We gather it in pieces each night, like someone watching a movie who keeps getting called out of the room. That is why teams spread across longitudes matter. One group catches the early beat, another picks up in their morning, sees the next beat, and stitches it to the first with care. When those stitched curves show a steady drum one week, then a drifting double beat the next, you are watching the interior respond to sunlight and spin. The motion is whispering about stiffness about internal structure, about whether the object is a monolith with scars or a stack of pebbles wearing a coat of frost. Every few nights, the angle from which we watch changes enough to alter the way the same spin looks. If the pole points more toward us, the light curve flattens because we're mostly seeing the same face over and over. If the pole is side on, the peaks sharpen because the silhouette changes more as it turns. When observers note that the curve shape shifts with geometry, even as the timing stays close, that is a hint that the underlying motion is consistent and the display is doing the shifting. When both shape and timing drift together, that is a hint that the engine itself is changing. New jets, lost fragments, a spin retuned by its own breath. Sometimes the brightness does something that feels less like a dance and more like a stumble. A sudden surge that can't be explained by orientation or a neat spin. That is when people whisper about shedding. A thin skin can split. A crust can fracture along a seam that was waiting for its moment. The piece that leaves does not need to be large to matter. It only needs to change how the light is scattered, or how the remaining body balances itself on the invisible fingers of rotation. After such a moment, the period can shift a little. The wobble can deepen. Future peaks can arrive not where you expect, but a few minutes before or after, as though the drummer has started to swing. There is another way to read the data that feels almost tactile. Smooth, predictable spins make light curves with rounded tops and bottoms, like a practiced skater leaning into each glide. Tumbling bodies make light curves with sharpened features, corners, shoulders, shelves, as if a facet flashed into view and then snapped away. When 3-eye atlas draws shelves instead of humps, when it draws corners instead of domes, the intuition that it is flashing facets grows stronger. You can almost feel a flat face sweeping a beam toward you, then a notch, then a cliff on the far side sucking that light away. We don't get to see the silhouette directly, but tricks help. Watch in different colours and you can learn whether the peak grew because a bright, icy patch turned our way or because a dusty, reflective ridge did. Watch at angles where the tail doesn't confuse the picture and you can isolate the heartbeat of the core more cleanly. Stack many nights and fold them on the best fit period, and the repeated pattern rises from the noise like a watermark. If the watermark itself seems to breathe, the period is wandering. If two watermarks compete, you have two clocks inside one object, and tumble is the likeliest clockmaker. When sunlight is strongest, near the moment of closest approach to the sun, the forces fighting over the spin are at their loudest. Jets are rowdiest. Torques add up faster. The core's skin is most likely to soften, release, or crack. If 3-eye atlas is going to change its spin state in a way we can catch, that's the season. Observers will bracket that interval with obsessive care, nights before to set the baseline, nights after to measure the aftermath. The before and after comparison reads like a diagnosis. Did it come through with the same rhythm, only louder? Did it pick up a hiccup it didn't have before? Did the wobble damp a little, as if the interior absorbed energy and settled? Or did the wobble grow, as if the interior rang like a bell? Damping matters because it hints at the inside. A rigid, solid chunk will keep an awkward tumble for a while, unwilling to redistribute the energy into heat. A looser body, full of joints and friction between grains, can convert wobble into warmth and settle into a single, simpler spin more readily. If weeks pass and the mixed beat calms into one clean tempo, you begin to suspect a more granular heart. If months pass and the mixed beat refuses to die, you begin to suspect stiff bones. All the while, a quiet threshold hovers nearby, the speed at which a small body without internal strength begins to lose the fight against its own motion. Most stony shards never spin faster than a handful of hours per turn unless they are held together by more than gravity. Most dusty comets keep gentler tempos still. Should 3I Atlas edge toward a shorter turn and flirt with that threshold, the risk of shedding goes up. The signs can be subtle, an extra plume here, a ragged edge there, a new persistent offset in the light curve that won't wash out. The team will measure and remeasure, cautious not to mistake weather for structure. But if the signs remain, coming apart stops being a dramatic phrase and becomes an honest description of a process that can happen grain by grain. None of these clues stand alone. A jet that turns the spin will also brighten the veil. A fragment that leaves will also change the spectrum of dust sizes in the coma and alter the way light is polarized on its way to us. A wobble will show up in timing and in the way the tail arcs. So the best pictures emerge when you set the clues in a circle and see if each points to the next without contradiction. If the period drifts in step with the nights when gas surges, if the curve's corners appear when the geometry makes facets more likely, if the baseline brightness climbs and remains high after what looks like a crack-up, then the story is coherent. Spin. Tumble. Perhaps a touch of shedding. The verbs fit together. There is a human side to this puzzle too. The people calling out times in control rooms learn the object's rhythm in their bones, even when the numbers are messy. They sense when a peak should have appeared by now and didn't, or when a dip is arriving too early, and they feel the prickle of something changed. They know when to steal 5 extra minutes before dawn to get one more point on the curve that might stitch the whole shape together. They also know the humility of being fooled by a thin cloud or a misbehaving focus, and the relief that comes when another sight confirms the same mischief under a cleaner sky. So the question hovers each night like a refrain. Is 3I Atlas spinning with poise, wobbling with a secret wobble, or loosening along seams we can't see? The honest answer is that it may be doing all three, now this one louder, now that one. Bodies are like that when they wander between stars and then wander through our light for a single season. What we can say, with the confidence that only patience buys, is that the brightness carries the signature of motion, the motion bears the fingerprints of shape, and the shape lives at the mercy of forces that never stop pushing. Watch long enough, and those pushes write a biography in flickers, a knock taken in some other system, a jet that chose a direction, a spin that learned a new step, and, maybe, a place where the traveller gave up a piece of itself and kept going. Dust is supposed to be the easy part. In the usual comet playbook, sunlight warms hidden ices, gas escapes, dust hitches a ride, and a soft, sun-pushed fan blooms away from the nucleus. The haze fades smoothly with distance, the tail curves predictably, and the whole scene behaves like fog in a steady breeze. Then 3I Atlas arrived, and the fog started making decisions. Edges hardened where there should have been none. Fans split into blades. Curves bent the wrong way for a night, then snapped back as if a stagehand had tugged an invisible wire. It looked like dust, but it didn't act like dust. Start at the centre, where the veil is densest. In many comets, the inner glow melts outward with a gentle slope. If you squint, you can almost see the math in the way the light softens. With 3I Atlas, the inner haze sometimes drops off too slowly, as if the particles linger near home, reluctant to leave. On other nights, it drops too quickly, hinting at grains that get grabbed and thrown outward with unusual zeal. That alone says the mixture is odd, some particles behaving like heavy snow that piles up at the curb, others like ash that rides any draft and vanishes into the room. Texture tells tales. Instead of a single smooth fan, 3I Atlas draws layered structures. Fans within fans, faint corkscrews that betray a rotating jet, wedges that brighten and dim as if a vent on the surface blinks. A narrow spindle, what observers call a spine, can appear down the tail's middle, a hint of bigger, lazier grains that barely feel the sun's push and simply trail behind. Flanking that spine, delicate feathers peel away, the calling card of lighter dust that listens closely to sunlight and the solar breeze. Hold those images in sequence, and you can watch the dust-size orchestra play sections in turn, basses, then violins, then the whisper of flutes. Colour is another voice. Many comet veils look a little redder than starlight because their grains reflect longer wavelengths more efficiently. 3-eye atlas shifts that tint back and forth. When a fresh burst pulls up pristine glass-like particles, the haze can look slightly bluer, the way clean frost glints. When stickier, carbon-rich dust dominates, stuff cooked by eons between the stars into dark, gummy mantles. The glow warms and deepens. Night to night swings in colour say the recipe is changing as different vents wake, different layers peel, and the traveller rummages through its pantry of ices and crusts. Angle can play magician with any tale, but here the tricks are bold. When Earth sits so that sunlight skims across our line of sight, the smallest grains can throw light forward like a sudden glare on wet pavement. 3-eye atlas leans into that effect with outsized drama, subtle one night, theatrical the next, implying a surplus of ultrafine, fluffy aggregates that pick up and scatter light in a way compact grains do not. Think soot-like clumps with a lot of void space, bigger cross-sections for their weight, more light to grab, more push to feel. Fluffy dust means sunlight's hand is heavier, and you can see that hand in the tail's exaggerated curve. But the curve won't sit still. Classic dust tails bend gently away from the sun. Fine grains are whipped hardest and arc quickly. Coarse grains lag behind. 3-eye atlas sketches that script, then writes in margins. A narrow, almost straight ray can spear outward for hours, as if a rifle of heftier grains fired from a single nozzle. Later, the same region fans wide with a gauzy sheet, the sign of lighter particles pouring through the same gate. The alternation suggests the vent is not a simple hole, but a shaped nozzle with changing pressure, maybe a mouth that sometimes coughs clods, sometimes breathes mist. Sometimes the sky plays a practical joke called an anti-tail. Part of the dust sheet looks like it points toward the sun. It's not truly pointing upwind, it's geometry. As 3-eye atlas lays down a carpet of heavy grains along its path, there comes a moment when our viewing angle lines up with that carpet, and a sharp, sunward-looking spike seems to sprout. With most comets, the effect is brief and tidy. With 3-eye atlas, it can be bolder and longer-lived, telling us the traveller laid down a dense, gravelly track, more pebbles than powder, weeks before, and we're catching the line where they pile into a lane. Then there are the odd straight striae, pale, parallel ribs laid across the tail at a slant. These ribs are time-stamped dust, each born in a short-lived episode when a vent went loud, lofted a preferred grain size, then quieted. Over time, sunlight sorts those grains by their area-to-weight ratio, stretching each batch into a long string. Stack several episodes, and the string sits side by side, a barcode of past breath. 3-eye atlas etches those barcodes clearly, meaning the object is pulsing rather than purring. Fits of activity, rests, then fits again. Move from structure to motion. The smallest grains behave like dandelion seeds in a steady spring breeze. They feel the sunlight's pressure almost as much as gravity and veer away. Larger grains act like apples tossed from a car window. They leave, but they hug the road. If you draw invisible maps that track grains of the same size and grains of the same launch time, most comets respect those maps. 3-Eye Atlas keeps the maps but scribbles over them. Some nights the light is dominated by ultralight fluff, other nights it's heavy grit. The result is a tail that can look thin and sharp on Monday, then broad and soft on Wednesday, even when the distance to the sun hasn't changed much. A dust source that keeps changing its mind is a dust source tied to complex terrain, ridges, pits and vents that switch allegiance as the traveller turns. Electric quirks creep in at the tiniest scales. Sunlight and the wind of charged particles can zap dust and give grains a surface charge. Most of the time, gravity and sunlight still run the show, but in very fine dust, a jolt can deflect motion just enough to draw needle-like rays that ignore the graceful curves around them. 3-Eye Atlas occasionally sketches these needles, not for days, just for hours, like cat whiskers, thin and stubborn, before the larger forces regain control and sweep the whiskers back into the main flow. The way the brightness falls off across the coma, the how quickly does the haze fade as you move outward question, can diagnose the traffic. A classic steady outflow draws a predictable slope when you measure brightness in concentric rings. 3-Eye Atlas sometimes draws a slope too shallow, a sign of a crowded inner highway where grains collide, fragment and refill the lanes. Sometimes it draws a slope too steep, a sign of a freeway suddenly clearing out because the grains are so fluffy that sunlight flings them away faster than usual. Either way, the traffic is not normal. Every grain is a tiny mirror with a biography. In our solar system, many are glassy silicates dressed in thin coats of darker organics. Between the stars, grains endure ages of radiation, coatings thicken, bonds rearrange, surfaces roughen into velvet. If 3-Eye Atlas carries that interstellar patina, its dust will scatter light differently, softer glows at some angles, deeper polarization at others, colours that drift as fresh interiors are exposed and then recoated by their own chemistry. That could explain why the haze sometimes looks aged and dull, then suddenly freshens after a crack or outburst exposes new material. The sky is not changing colour, the dust is changing character. Gas and dust decouple too. A razor-thin ion tail, straight, brittle, magnetically steered, can slice one way while the dust spreads another. When the thin needle brightens but the dust fan ignores it, you learn the gas is having its own day and the solids are holding steady. When the dust swells while the needle stays shy, you learn the vents are lofting grains without belching much gas, perhaps because heat is freeing crusted layers rather than boiling deeper ices. 3-Eye Atlas leans toward dust-rich moods, thick veils with only modest gas signatures, as if the traveller's crust is ready to shed at the slightest provocation. Time makes a map. Hours after a burst, you see a small bright wedge hugging the nucleus. A day later, that wedge has stretched into a banner. 2 days later, it becomes a rib in the tail, and a week later, it's a faint, far streamer, only visible when you add many images together. Track a few of these episodes at once, and you end up with a layered scrapbook. This was Tuesday's dust, this was Friday's, all fluttering in the same wind. 3-Eye Atlas fills that scrapbook quickly. It has a lot to say in dust, and it says it in short sentences. None of this would be legible if the grains were all the same. The story only reads because the sizes and structures differ dramatically. Fluffy clumps the size of smoke particles ride the light. Sand-sized bits lag and define the spine. Pea-sized clumps, rarely but memorably, peel away like sparks that refuse to die. When a pea-sized piece goes, the veil doesn't flare much, but the spine thickens subtly and stays thick. A week later, observers still see that extra heft in the trail long after the flashy feathers have washed out. That persistence is why a single brief event can reshape the tail's personality for days. At the root of every fan and feather is geography. Picture a vent carved into shadow, waking only when the traveller's roll swings dawn across its lip. Imagine a crack on a ridge that funnels gas into a thin sheet, like wind squeezing through a canyon. Imagine a hollow that traps pebbles until a deeper tremor shakes them loose. As 3i Atlas rotates, each feature takes a turn facing the sun, and the tail updates like weather maps hour by hour. The result is not a single obedient plume, but a chorus of accents, each with its own cadence and grain preference. Observers adapt. To hear the heavy grains, they track the nucleus and measure close in, keeping their measuring circle tight so faint feathers don't drown the core. To hear the fluff, they widen the circle and accept a little smear, trusting that the big picture matters more than crisp edges. They stack frames to reveal the faintest ribs, subtract stars to keep the canvas clean, and check in multiple colours to separate fresh, gas-washed brightness from dust-surfaced shine. With 3i Atlas, those choices change the story more than usual. Tight apertures make it look tidy. Wide ones reveal the mischief. Watch long enough and you learn to expect one last trick, the neckline effect. Dust shed at a particular moment, when the traveller was at a particular place in its path, can reconvene into a thin line under the right geometry months later, as if the past left a thread you can pluck. 3i Atlas plucks several. In late views, faint lines blossom where no line was before, ghostly runways pointing back to older outbursts. It's not nostalgia, it's physics with a good memory. Dust is often treated like background decoration. Here it's the main character. It carries signatures of interior strength, or lack of it, of surface crust and buried frost, of vent shape and spin, of time spent wandering between suns. In the glow of 3i Atlas, every grain reads like a postcard, some stamped from a deep cryogenic past, some smeared by interstellar weather, some printed moments ago by heat and stress. Put the postcards in order and you get a moving picture that breaks the simple rulebook. The fog learns edges, the breeze writes barcodes. The tale forgets to behave and, in forgetting, tells us exactly where this traveller has been and what it's made of. If you want to understand a traveller, watch what it breathes when the sun warms its skin. The first wisps off 3i Atlas are not just steam, they're fingerprints. Every molecule that sloughs into space carries a hint of where this body was born and how it has been changed by the deep cold between stars. Some ices wake early, long before water stirs. Others need noon, not dawn. When those different wake-up calls mix, the coma becomes a weather report in code. Begin far out, where sunlight is little more than a suggestion. The usual water ice sleeps there, locked tight. But a handful of so-called supervolatiles, gases that can wriggle free at colder temperatures, are already twitching. Carbon monoxide is the classic early riser, a ghost that slips from shadow with the least provocation. Nitrogen can be even more skittish if it's present, sensitive to a chill that would leave water unchanged. Carbon dioxide sits between worlds, too shy to leap at a whisper of light, bold enough to move well before water does. If 3i Atlas carries these ices near its surface, they become the first voices we hear, faint, high-pitched notes that don't need much heat to sing. Those first voices shape everything that follows. A breath of carbon monoxide from a shaded hollow can turn the body into an unbalanced engine, pushing dust out from one patch while the rest of the surface looks inert. A tuft of carbon dioxide from a rim can loft particles that water could never lift at that distance. Observers learn to watch for these early acts in colours and lines, subtle features in light that hint at what has boiled off and what remains stubborn. On some nights the coma looks cleaner, as though a clearer gas has rinsed the immediate neighbourhood. On other nights, the glow bears more of a dusty, baked tint, as if fragile organics have been brushed free and set adrift. Now bring the traveller closer. Sunlight grows teeth, water's icebox latch finally clicks. Where carbon monoxide and nitrogen deal in whispers and veils, water vents like a crowd, louder, more democratic, prone to turning many small pores into a mass exhale. The transition is rarely smooth. 3 things happen at once. First, jets that were already alive get louder. Second, new vents wake in places that showed no previous activity. Third, and this is the trickiest part, the structure of the ice itself can change. A region of water ice that has been amorphous, full of tiny traps and cages, can reorganize into a more orderly form. When it does, it releases whatever it had been holding: carbon monoxide, carbon dioxide, even noble gases if they were tucked away. A sudden cough in the light curve, the kind that looks less like weather and more like the floor giving way, can be the signature of that internal replumbing. Those cages deserve a moment. Think of water ice as a host that can form guest rooms. Under the right conditions, it can make clathrates, delicate lattices that bottle small molecules in cages of water. Heat the lattice and the room's empty in a rush, even if your thermostat hasn't reached the point where the guests would have left on their own. That's how you can get a burst rich in carbon monoxide or methane at a temperature where, on paper, they should be reluctant. If 3i Atlas is built with these frozen guest houses near or just beneath the skin, the keys to those rooms, sunrise, seasonal tilt, a passing warm spell, will write themselves as sudden bright fans, brief and repeatable when the geometry lines up, then silent for days. Beneath the chemistry sits history. Interstellar space is not gentle. For ages, cosmic rays sandblast and splice, building crusts out of simpler ingredients. The topmost millimeters can become darker, tougher, more reluctant to give up what they hold. Radiation cooks thin films of organic gunk, tar-like layers that trap ices until a crack lets the pressure out. If the surface of 3i Atlas is armoured this way, then gas can collect underneath like breath under ice on a winter pond. One hairline fracture later, you get a pinched whistle or a sudden gust, not a steady breeze. That punctuated release is exactly the kind of rhythm we see when bursts lay sharp ribs across the tail and then vanish. Some clues hide in the faintest changes of colour. Fresh, water-rich jets can make the inner coma look a little cooler in tone, the way frost shifts a scene. Carbon-heavy releases warm the hue toward the ruddy. The swing needn't be dramatic to be meaningful. A small, consistent tilt over several hours as a jet rotates into sunlight and back into night can be enough to tell you which hose is open. Stack a week's worth of those tilts, and you can draft a map of active patches with labels like early riser, midday only, and won't shut up after sunset. There's also the curious business of what doesn't show. If gas is shy while dust is bold, then 3i Atlas may be coughing up material by mechanical means as often as by boiling. Thermal stress can flake a crust. Tiny quakes, caused by spindrifts or by the contraction and expansion of a brittle shell, can shake loose aggregates that drift without any strong gas to push them. In that case, a dust-rich haze forms without much gaseous perfume in the spectrum. In other words, absence becomes a kind of presence. The quiet of certain lines in the light suggests the loudness of cracking and crumbling. When gas does reveal itself, timing is a teacher. Early activity far from the sun points to supervolatiles near the surface or trapped gases being freed by structural change. Later blooming that spikes at specific angles hints at pockets of water ice buried under insulating crust, exposed only when the local topography, cliffs, pits and overhangs, leans into the sun just so. A jet that strengthens as the object rotates into afternoon and then dies abruptly at sunset tells you the plume is surface controlled. One that lingers well into local night suggests heat soaking down and feeding a deeper reservoir that doesn't care what the sunlit hour says for a while. Even the way the coma thickens with distance from the core tells on the gases. When water dominates, you often see a steadier, rounder halo close in, because water's heavy breath drags fine dust along in a broad, democratic way. When carbon monoxide does the talking, structures sharpen and can extend farther before the dust thins, because the gas is faster, more focused, and better at lofting material that resists water's slower push. 3i Atlas draws both portraits on different nights, as if different lungs have taken turns. One of the strangest pleasures in this work is watching for chemistry that shouldn't be easy. Oxygen in the coma can have more than one parent. Sometimes water breaking under sunlight will do. But if you see a little excess in the wrong moment, you start to wonder about inherited oxygen-bearing ices created in a cold cloud before any star was born. Likewise with nitrogen, it is bashful, but its presence hints at a nursery so cold and shaded that nitrogen could condense and stay. If 3i Atlas whispers of these delicate stocks, even faintly, it is telling us it remembers a time and place more like the outskirts of a young, dim system than the busy inner lanes of ours. Isotopes are quieter still, but their accents matter. A slightly heavier flavour of hydrogen locked in water carries the temperature of formation like a childhood dialect. Carbon's subtle choices between two stable types speak to the family of organics the body grew up among. We may not get clear, clean measures in a single brief season, but even broad hints, heavier than usual, lighter than the family next door, narrow the roster of possible birthplaces. A voiceover doesn't need the numbers to convey the idea. 3i Atlas may be carrying a memory of a colder nursery or a different recipe book than our comets use. As the sun's touch deepens, seasonal effects bloom. If the spin axis is tilted, one hemisphere can enter a raw, relentless summer, while the other squints through a long, stingy winter. The summer side will look freer with gas, its crust opening vents and keeping them open. The winter side will store pressure for weeks, and then let go in a single risky event when a crack finally stitches the two worlds together. The coma, seen from far away, records this with a bias. Fans that favour one side, tails that carry a permanent lean even after you correct for viewing angle. The chemistry rides along, skewed by which kitchens are open. All of this depends on depth, the handful of centimetres that sunlight can bully, and the metres below that remember yesterday's heat and deliver it late. That thermal skin sets a beat. Gas you see at sunset may have been cooked at noon. A midnight event may be the delayed sigh of heat that walked down a porous path and found a pocket of unlocked ice. Follow those delays across rotations and you can reconstruct the plumbing. Fast, direct channels that answer immediately, slow, insulated pathways that answer in the small hours, dead ends that answer never. Sometimes the coma brightens in a line too narrow and too straight to be driven by gas alone, a filament that looks like a fired hose. Those can be the signatures of chunks, small, bright clods of ice-rich material, peeled from the skin and spinning as they drift. They are brief, and they evaporate quickly, but while they live, they contribute a sudden local fog of their own. If 3i Atlas shed such clods, we would see little lights that fade as they fly, each one a travelling micro-comet with its own tiny atmosphere for an hour or a day, seeding the broader coma with fresh molecules that water cannot account for by itself. There's a hierarchy in the scent of a coma that anyone can appreciate, even without a spectrum in hand. Clean, quick activity feels like glass cold-washed, edges crisp, structures tidy, dust modest. Dust-heavy activity feels like flour bursting from a cupboard. Everything softens, Details blur. The room takes on a taste. 3i Atlas lurches between those moods faster than most locals, which is another way of saying its pantry is messy. Layered ices, armoured crust, guest room cages, long-soaked reservoirs. They're all present in proportions that shift as the object rotates and as its path puts different latitudes to the flame. And the tale's long memory folds chemistry into time. Carbon monoxide-rich episodes lay down strings that stay coherent for days, because the grains they lift share a size and a story. Water-dominant days throw a broader sheet that thins more quickly. When you back away and look at a week's worth of frames all at once, the tale looks like a loom, narrow, bright threads woven into gauze. Track the bright threads, and they point back to the moments when supervolatiles ruled. Track the gauze, and it points to waters raw. In the end, what makes these ices from elsewhere so compelling is not that they are exotic for the sake of being exotic. It's that they unlock behaviour we struggle to mimic with our familiar recipes. Early breath far from the sun, sudden gusts when a lattice reorganises, vents that stay open past sundown because deep channels stay warm, dust-rich hazes without the gaseous chorus you expect. Each of these tells you that 3i Atlas is not just a cold thing warmed. It is a layered archive of a place that froze differently, a place where certain molecules were plentiful and others scarce, a place that then endured a long winter under radiation that baked a shell around its heart. So we watch for the small telltales, a colour shift at dawn, a rib that matches a phase lag, a narrow ray that repeats every turn, and so must be tied to a stubborn vent. We gather them without hard formulas because the sky provides its own diagrams if you let it. The molecules that leave are honest. They cannot pretend to be born under a different sun. They write their names in light and timing. Read that handwriting carefully and you can hear the accent of another system in the breath of 3i Atlas. Speed changes the kind of story you can tell about a thing. With a familiar comet, you get time to breathe, time to watch it crawl across the same stars night after night, time to compare 1 week's behaviour with the next. With 3i Atlas, everything is compressed. The clock runs faster. The skyplane motion is brisk enough that a single exposure can turn a point into a dash if you're not careful. The object behaves like a courier who never stops walking while you try to read the address pinned to their coat. You can read it, but only if you walk with them and keep pace. The most immediate problem with speed is simple. Light is precious, and motion steals it. Telescopes collect photons in little cups called exposures. For steady stars, you can hold the cup open longer and catch more light. But if the target moves quickly and you track the sky instead of the object, the light smears into a streak and dilutes itself across many pixels. Track the object, and the stars turn into lines instead, which makes calibration trickier but keeps the courier's face sharp. Either way, someone is streaking. Observers switch to non-sidereal tracking, following 3i Atlas itself, because a sharp target beats sharp stars. Then they shorten exposures to keep the point tight, accepting a hit in sensitivity. It's like photographing a sprinter under stadium lights. Blur is the enemy. You crank the shutter and live with the grain. Speed makes timing ruthless. When the object crosses from one constellation into the next in a single night, your window is not just after twilight, it's after twilight and before the object drops behind that mountain, and before the moon drags the background too bright, and before dawn paints the air with blue. Even if the sky is perfect, 3i Atlas can outpace you by sliding into a geometry where the angle from Earth spoils the view, then sliding out again before your next clear night. The best you can do is coordinate across longitudes so that someone catches the baton when you cannot. A fast mover turns the planet into a relay team. Speed also changes what heat means. For a slow visitor, the days near the sun are a season. For 3i Atlas, they're a weekend trip. Materials that would normally settle into a rhythm barely have time to find one. A patch of ice on a wall that might spend an entire week under aggressive noon for a local comet might get only hours of harsh light here before the angle tilts away. That compresses the chemistry. You see sudden on-off switches instead of slow ramps, sharp ribs in the tail instead of languid fans. Gas that would have diffused into a broad, steady coma over days becomes a series of pulses stamped onto the dust like exclamation marks. Even gravity tells a different tale when speed is involved. Everything falls faster as it dives toward the sun, and faster still when it already had a head start from another star. Inbound, the acceleration can make the skyplane rate jump between nights. Outbound, the rate can stay high longer than your instincts expect, because leaving doesn't mean lingering. That matters when you're stitching positions into a path. Early on, the uncertainty in where to point tomorrow can be large enough that a small telescope might aim wrong by a sliver and miss a whole night. Each successful measurement tightens the prediction, but there is a period at the start where speed and uncertainty work together like two mischievous hands, nudging the target just out of your field if you let your attention slip. Spectroscopy becomes a tightrope. To split light into its chemical fingerprints, you feed it through a narrow slit. With a sluggish comet, you can line up the slit and let the object drift slowly inside it while the clock ticks. With 3i Atlas, the slit alignment must be fussed over like a violin and the exposure shortened before the courier steps out of frame. You accept noisier data or you build up signal by stacking many short shots, each one kept on the rails by precise tracking. Even then, the coma itself is changing quickly. You're not just measuring faint lines, you're aiming at a moving, evolving target that insists on being different 40 minutes from now. There is a quieter trick speed plays. It magnifies little pushes. Non-gravitational nudges, tiny jets acting like thrusters, sunlight pushing on dust grains, are always present. For a slow mover on a bound path, those pushes accumulate over months in ways we can model and subtract. For 3i Atlas, the same little pushes can show up as noticeable jogs in the short term because the object covers so much sky while the jets flicker on and off. A plume that turns on for an hour is a tickle on a lazy comet. On a fast, unbound traveller, it can shift timing enough that the next night's peak brightness arrives earlier or later than you'd charted. It's not chaos, it's responsiveness. The courier leans into a gust and you can see the lean. All of this reaches down into the pipeline where discoveries are made and confirmed. Survey software links detections into tracklets, short arcs across a few frames, and then links those into paths. When a thing is speedy, the tracklets cross more sky and intersect more background junk, glints from satellites, faint ghosts from optical quirks, cosmic ray scratches. The algorithm must be both pickier and braver. Too picky, and you toss the courier's trail as noise. Too brave, and you chase phantoms. The safest way to win is to get confirmation fast, but confirmation requires pointing a different telescope at the moving target right now. Not tomorrow, because tomorrow the courier is 3 doorways away. Speed sabotages complacency and photometry too. If you measure brightness with a circle that's too big while tracking the object, you catch not just the point but the smeared starlight around it, those star trails pouring through your measuring cup like bright scratches. Too small, and you clip the object when the tracking isn't perfect. Observers compromise, then build models of the star trails to subtract their contamination, then cross-check against shorter, sharper frames to make sure the subtraction didn't erase real wiggles in the light from 3i Atlas itself. You're not just measuring how much light, you're discriminating between light that belongs to the courier and light that belongs to the moving scenery. There's a psychological effect, too. When a thing is fast, the temptation is to chase only the dramatic moments, peak brightness, closest approach, the night the tail looked strangest. But speed means what happens in between those headline moments matters more than usual, because in between can be an entire phase. A jet that is active for 2 hours is a footnote on a comet that hangs around for months. It is a main chapter for 3i Atlas. So teams plan dense cadence, rapid-fire sequences that trade depth for continuity on purpose, so that small, fast events don't slip between the comb's teeth. Parallax becomes a tool and a trap. Two observatories far apart on Earth do not agree perfectly on where a nearby fast mover sits against the stars, simply because their viewpoints are separated by thousands of kilometers. For slow objects, you can ignore that for a night and fix it later. For 3i Atlas, the difference can be measurable in single frames, which is annoying until you realize it's also leverage. Combine those slightly different views carefully, and you compress the uncertainty faster than you could from one sight alone. It feels like triangulating on a moving car using 2 street corners judiciously, with the car insisting on turning a block earlier than your intuition says it should. Twilight steals more than it should. A brightening sky shoves your detection limit up, and a fast target climbs into and out of the twilight wedge before night has fully taken the stage. That's painful because interesting geometry often happens close to the sun in the sky, where dust tails are best seen, and where the action in gas lines can be rowdiest. You can try for dawn and dusk grabs, those stressful minutes when you fight gradients in the background and airplane contrails. But those grabs are easiest to botch when the object's rate on the sky is largest. A single thin cloud that you'd forgive at midnight becomes a showstopper at the edge of day when you only had 10 minutes to start with. Speed reaches into the tail as well. Dust grains lofted at 1 hour are already far downrange a day later, so the tail records a week of behavior like pages fanned out on a table. With a slow comet, yesterday's dust sits near today's dust and the pages overlap. Differences blend. With 3i Atlas, the pages separate. The ribs and striae pull apart cleanly enough that you can assign them to specific events and even estimate how long each event lasted, just by measuring the spacing. The tail becomes a timeline written in distance, a storyboard that speed itself has stretched for you. Thermal lag works differently at this pace. Heat that soaks into the surface can take its time emerging, but the object refuses to loiter under any one sunlit angle. As a result, you see vents that come on late, not because the source is lazy, but because heat was still marching underground when the surface had already turned toward afternoon. By the time the subsurface reservoir is fully awake, the surface has rotated, the jet points somewhere else, and the whole pattern learns a strange syncopation. On a slow visitor, you'd call this a seasonal effect and watch it mellow out. On 3i Atlas, it never quite settles before the geometry and the distance change again. Even radio and radar, if attempted, inherit headaches. A fast target demands quick adjustments in frequency to keep echoes centered, and small errors pile up because the line-of-sight velocity is changing as briskly as the skyplane motion. You can do it, but the system behaves like a manual transmission on a steep hill in traffic. Doable, but you never stop shifting. For amateurs with sharp rigs, speed is both an obstacle and an invitation. The obstacle is obvious. You need precise, non-sidereal tracking, or disciplined shift and stack, where you digitally slide each short exposure along the predicted motion before adding them. The invitation is less obvious but sweeter, because 3i Atlas draws visible change over hours. A dedicated observer can make a meaningful contribution in a single night by catching the start and stop of a small outburst or by measuring how the tail's angle tilts with phase. On a slow object, that work would be redundant. Here, it's new information. Origin stories hide inside velocity, and speed gives you hints even without chalkboards. A traveller this quick didn't amble out of a local freezer. It was thrown by the restless gravity of giant planets in some other system, by the shoving and jostling of early planetary construction, by resonances that kicked it one too many times, by a star's changing neighbourhood that made far-orbiting bodies fragile. Over enormous distances, those little shoves add up, and when the object finally finds our sun, it arrives with momentum from a life we can't see. We read that past in the present by measuring how fast the courier crosses our platform and which way it points when it does. The numbers live in tables. The idea lives in the way 3i Atlas refuses to slow down for our benefit. Speed also trims the list of unlikely events. Capture by a planet. You'd need a near miracle of timing for a fast, unbound object to be netted into a local loop. Deep deflection into a new type path? Possible in principle, but geometry and timing stack odds against it when the path races by. That clarity frees observers to spend less time gaming out exotic detours and more time draining every bit of signal from the moments we are guaranteed. Inside the data, cadence becomes the real currency. You can have a giant mirror and still miss the heartbeat if you take one deep exposure an hour apart. You can have a modest mirror and win if you take a stream of short images and capture the rise and fall of a jet. That's counterintuitive until you remember the courier refuses to pose. Detail is a matter of time sampling as much as aperture, and 3i Atlas rewards those who remember that truth while they're yawning at 3 in the morning and tempted to go for just one more deep shot instead of 10 quick ones. If there is a grace in all this, it's that speed concentrates attention. You make decisions faster, you share results faster, you cross-check faster. You accept that a beautiful plot made next week from last night's data is less useful than a rough, honest plot made now that tells the team which filter to try before dawn. The object trains the community as it passes, the way a swift guest trains a kitchen to move with efficiency it didn't know it had. And in that bustle, the puzzle of speed stops feeling like a penalty and starts feeling like a gift, a clean, crisp constraint that forces the real character of 3i Atlas to show itself in the open, because there isn't time for it to pretend to be anything else. Line up 3 strangers at the door, and you start to notice the family likeness and the family feuds. The first one, Oumuamua, slipped in like a rumour, a point of light with no veil, no obvious breath, but a light curve so dramatic it hinted at a stretched, faceted body, thin, elongated, and possibly tumbling. It was quiet in gas, loud in mystery, and to everyone's surprise it seemed to feel a small extra push that gravity alone could not explain. The second Borisov was the opposite kind of statement. A textbook comet from another star. It wore a coma proudly, grew a tail, shed dust and gas in ways we recognized from our own long-period visitors, and whispered of chemistry that felt primordial but not impossible. And now there is 3i Atlas, a traveller that refuses to sit neatly on either end of that spectrum. It arrives with a passport signed by the galaxy, but the way it behaves in our light keeps sliding between familiar and odd, as though it learned its manners in a different house and is trying them out at our table. The Oumuamua lesson was humility. We thought we knew what an interstellar object should look like, icy, ventilated, dust-laden. Instead, we saw something that did not grow a visible coma, spun with a complicated beat, and yet drifted from a purely gravitational path by just enough to keep theorists up late. Explanations competed. Exotic ices that leave almost no trace when they vaporize, fluffy sheets that catch sunlight like sails, slow release of gas too subtle to paint the usual halo, each possibility pointing back to a place of origin with different temperatures and different inventories of ices. Whatever the answer, Oumuamua told us that interstellar is not a single template. It is a population word, and populations have outliers. Borisov, meanwhile, was the comfort. It was dusty, blue-tinged in its gas, and structured in ways we could pass. Jets, striae, a coma whose brightness fell off with distance about the way you'd expect for a steady outflow. It seemed more fragile, more comet-like in the traditional sense, a snow and dust aggregate that woke up under the sun and said so out loud. Its chemistry suggested a cold nursery and a long sleep, with super volatiles joining water in the early act and staying active deeper in. If Oumuamua forced us to widen our definitions, Borisov reassured us that some of our old instincts still work beyond our borders. Stand 3i Atlas beside those two and you can start to sort traits. On some nights, it wears its dust like Borisov did. Fans within fans, ribs that timestamp bursts, an anti-tail when geometry and gravel align. On other nights, it keeps its secrets closer to the skin, refusing easy measures of gas, letting brightness flicker in ways that feel more like shape and spin than like steady exhale. Where Oumuamua refused a veil entirely, 3i Atlas shows one, but it does not always obey the tidy rules dust usually follows. Where Borisov's activity ramped in a way that felt seasonal and smooth, 3i Atlas sometimes speaks in fits and starts, as if parts of its crust open as trapdoors rather than doors. Spin is another mirror. Oumuamua's light curve swung so widely that people joked about a cosmic spatula. The amplitude suggested an extreme silhouette, or a very reflective face alternating with a darker one, and the timing hinted at a complex, maybe tumbling state. Borisov's heartbeat was gentler, more like a many-jet comet whose rotation shows through only when you factor out the broad glow. 3i Atlas sits between. At times its curve suggests a potato-shaped core flashing facets. At times it layers a wobble over a cleaner beat, hinting that jets are talking it on the fly. If Oumuamua was a riddle about surface physics and Borisov was a lesson in comet plumbing, 3i Atlas is a negotiation. How does a not quite quiet, not quite rowdy body keep its balance when sunlight asks hard questions quickly? Even the tails teach by comparison. Borisov's was classical, dust curving away, an ion sliver pointing almost straight from the sun under the interplanetary magnetic field's guidance. Oumuamua gave us no obvious tail, so we learned to read absence, the absence of glow, the absence of blue needles, like a presence. 3i Atlas writes dust in bold strokes one night, then in calligraphy the next. Spines that imply hefty grains trail close. Feathers of fine fluff peel away. Narrow rays switch on and off as vents rotate in and out of dawn. All of this feels like a cometry dictionary we already own, but shuffled, underlined in new places, and annotated in a hand we don't fully recognize. The chemistry too lines up like 3 notes on a scale. Oumuamua's spectrum was a challenge. If there were gases, they were whispered, and the extra push it felt might have come from something that evaporates without leaving an obvious signature, or from sunlight playing tricks on a very low-density structure. Borisov announced its contents more clearly. Early rising gases stirred before water took over, and the balance of volatiles suggested a cold formation zone that could trap species that don't linger near our sun. 3i Atlas seems to carry both the shyness and the boldness. Some episodes look like CO or CO, 2-driven breath rising early and fast. Other times the dust dominates with little gaseous perfume, as if thermal stress and crustal flaking are putting solids in the air without deep reservoirs boiling in chorus. It's not contradictory, it's layered. The pantry is varied and the cook is moody. Dynamics, how each traveller moves, round out the comparison. Oumuamua and Borisov arrived on unbound paths that sliced through our orbital sidewalks, and 3i Atlas does the same. But Oumuamua's lack of visible coma made non-gravitational nudges stand out more starkly. Borisov, with its frank activity, wore those little pushes inside the larger cometary weather that we expect and model. 3i Atlas, because it shows activity that waxes and wanes, gives us a harder accounting task. Which part of the path's small deviations are jets, which part is measurement, which part is geometry? Playing tricks as our viewpoint slides under and over the object's plane. The answer changes with time more than it did for the first two, and that, by itself, is a clue about surface patchiness and the depth of its vents. Then there's what each one did to our infrastructure. Oumuamua taught us to react to a point-like interstellar visitor with no coma and still wring meaning from its flicker. Borisov trained the community to treat an interstellar comet like a high-priority, high-cadence target. Spectra at dawn, polarimetry at dusk, images in multiple bands night after night, worldwide. 3i Atlas inherits those reflexes. Non-sidereal tracking as default, short exposures stacked smartly, fast sharing of coordinates, and colour work folded into the nightly plan. Because it behaves like a hybrid, sometimes comic classic, sometimes comic cryptic, it's pushed observers to run two playbooks at once. The listen for gas script and the read the light curve for shape and spin script, flipping between them in real time as conditions and behaviour change. Public imagination is another axis. Oumuamua drew bold speculation, engineered sails, unusual ices, because it slipped between categories and left a small acceleration to explain without a veil to point at. Borisov, by being a normal comet from an abnormal place, made the conversation calmer and more grounded. Fascinating, yes, but not an affront to our catalogue of natural processes. 3i Atlas sits in the conversational middle. It gives enough cometary behaviour to keep the wildest ideas in check, yet enough anomalies to keep the door open to materials and structures we don't see often at home. It invites serious curiosity rather than verdicts. It says, broaden your chemistry set, update your surface physics intuition, and don't be surprised if the same body behaves differently week to week, because its skin is a quilt, not a uniform coat. Consider, too, how each object sketches the diversity of its birthplace. Oumuamua may have been shaped by processes that strip and bake volatile pore crusts, catastrophic fragmentation, prolonged radiation, or gentle compaction of something foamy. Borisov looks like debris slung out from a cold, volatile, rich nursery, with plenty of loosely bound aggregates that woke under our sun and fell apart in predictable ways. 3i Atlas hints at a third style. A traveller carrying supervolatiles near the surface in places, deeper water reservoirs elsewhere, and a radiation-toughened rind that opens not smoothly, but in episodes. That mix suggests a natal disk with temperature gradients and a history of jostling, perhaps giant planets migrating and throwing leftovers around, perhaps slow gardening by micrometeoroid impacts that built layered crusts before ejection. On the practical side, the detection stories rhyme but don't repeat. Oumuamua's discovery came late in its visit. We saw the back half of the play and had to infer the first acts. Borisov was found earlier relative to its peak, which let the world plan a campaign across months. 3i Atlas benefits from both lessons. Surveys now scan wider, link tracklets faster, and push out alerts in near real time, so a traveller with speed has a better chance of being chased while the chasing matters most. That is why 3i Atlas arrived not as a single surprising night, but as a coordinated season, with amateurs and professional teams sharing images and pruning false alarms quickly. The improved choreography is part of the science. The object taught us to dance by forcing tempo. Another comparison that matters is resilience. Borisov shed material dramatically. Its tail told stories of breakage and dust-driven fading that made sense for a fragile snowball built far from any star. Oumuamua, if it shed anything, did so stealthily, holding a silhouette and a quiet skin. 3i Atlas shows signs of both toughness and brittleness, depending on where you look. Some jets seem to push without tearing their vents wider. Others seem to unlace crust into clods and fluff that rewrite the coma in hours. That patchwork resilience says something about internal glue, how grains lock and unlock, how pores link into channels, and that in turn reflects the pressures and temperatures of the object's formative years. Light itself behaves differently across the trio. Oumuamua's colour was reddish, a sign of processed organics on the surface, and the polarization of its reflected light hinted at roughness at small scales. Borisov's dust polarization and colour matched the higher end of what we see in solar system comets, consistent with fresh, fluffy aggregates. 3i Atlas swings between freshened looks after bursts and weathered looks after quiet stretches, as if exposing fresh interiors and then quickly dressing them in a thin coat baked by our sun. The swing is part of its character. It lets us watch surface evolution on human timescales, whereas with the first two we mostly saw a single state, quiet and odd in one, loud and familiar in the other. When you ask what the three together say about the galaxy's leftovers, a picture starts to form. Ejection is common. The void between stars is not empty of small bodies, some compact and tough, some fragile and volatile rich, some layered and moody. The odds that we'd get a quiet shard first, a classic comet second, and a mixed behaviour traveller like 3i Atlas third are not cosmic theatrics. They're a reminder that selection effects rule what we notice. Pointed surveys catch what is fast and bright enough. Improved cadence catches behaviour we once would have missed. The more we look, the more the catalogue fills not with repeats of a single archetype, but with plural archetypes that overlap and blur. There's a moral hidden in logistics. Oumuamua punished delay. By the time many instruments could respond, it was already faint and leaving. Borisov rewarded planning. Large mirrors and small alike could take turns and build a deep record. 3i Atlas rewards flexibility. Nights swing from spectroscopy to photometry to wide-field imaging because the object changes what it offers as geometry and activity evolve. It has trained the community to switch filters on the fly, to accept shorter exposures for cadence, to hand off targets across oceans without ego, and to publish provisional results that can actually steer the next night's plan, rather than settle for polished papers that arrive long after the moment has passed. Even our metaphors got better because of the contrast. We learned to talk about breath and plumbing and skin with more care because we saw a nearly airless body act like it had a lung you couldn't smell, and we saw a standard comet cough and crumble in ways that tracked with terrain, and now we see 3i Atlas doing both in turns. We learned that tail can mean gravel road, silk sheet, barcode, or needle, sometimes all in the same 3-day run. We learned that spin can be a clock, a confession, or a slow argument with sunlight. Place the three on a mental plot, not with numbers, just with instincts. Oumuamua sits out on the quiet coma, strong shape signal, odd push corner. Borisov sits far on loud coma, standard comet physics, gravity, plus modest extra nudges. 3i Atlas occupies a neighborhood between them and slightly above the plane, in a region labeled layered behavior, patchy vents, dust that changes its mind. That point on the map was empty before. Now it has a name you can say aloud, and because it has a name, future visitors can cluster there or avoid it, and will build a genuine understanding of how crowded each neighborhood is. If you keep the trio in view, you also see how our questions matured. After Oumuamua, can a body be pushed by something we can't see in the coma? After Borisov, how different are interstellar comets from ours in detail rather than in headline? With 3i Atlas, how do layered volatiles and a crust seasoned by deep space produce a time-variable personality under a fast, one-pass geometry? Each question is less about surprise and more about mechanism. That is the shift from marveling to measuring. It means the next discovery, whether quiet, loud, or mixed, will arrive to a world that already has the right questions written on the whiteboard, ready to fill in with the specifics of a new traveller's breath, dust, light, and path. And in the simple act of standing these three beside each other, we've gained a scale. We can say, without reaching for arcane symbols, that interstellar visitors can be silent shards, standard comets, and something in between that changes mood as it turns. We can say that sunlight can push in more ways than one, that gas can leave signatures or hide them, that dust can behave like fog or like confetti depending on who is breathing and when. Most of all, we can say that 3i Atlas widened the middle ground, and the middle ground is where populations are defined, not by one icon and one exception, but by a spread of behaviours that make sense together once you've seen enough to believe they belong to the same larger story. Take a stone and leave it on a windowsill for a single season, and you'll barely notice a change. Leave it on a beach for years, salt, wind, sun, footsteps, and it turns into something else entirely. Interstellar weathering is the beach, stretched across light years and lifetimes. 3i Atlas is a traveller that has been sanded, stained and stitched by the slow violence of space, the constant patter of dust no bigger than smoke, the bath of high-energy particles that pass through rock as if it were tissue, the ultraviolet light that unknits and reknits bonds, the cold that fuses grains together grain by grain. By the time such a body steps into our sunlight, its skin is less a surface and more a record. Start with radiation, the most patient sculptor. Out between the stars there is no thick atmosphere to soften the blow, no magnetic cocoon to bend the charged rain aside. Cosmic rays punch into matter and leave tracks of broken chemistry behind them. Water ice that begins as tidy crystals can be shaken into a more chaotic form. Simple molecules split and recombine. Some escape, some stay and bind into larger, tar-like substances that darken and redden the skin. Layer this for ages and you get a fragile varnish, call it a rind, that is both armour and trap. Armour, because it seals in the more skittish ices below. Trap, because it can bottleneck pressure beneath until one crack, one noon, one tremor lets everything go at once. Beneath that rind, time knits. At temperatures that would shatter steel but leave ice tough, neighbouring grains slowly grow little necks where they touch. That quiet welding, sintering, stiffens a surface without making it strong in the way a boulder is strong. Think of a meringue toasted on top, a crisp shell over foam. It resists a fingertip, then caves suddenly. 3i Atlas may wear exactly this kind of desert armour. It holds together under gentle pushes, and then, when a jet insists or a spin tugs too hard, it gives up not as a single chunk, but as lace. Dust adds another kind of scarring. Micrometeoroids, sand fine and faster than bullets, pit and polish at once. Each hit melts a speck, splashes a bead, vitrifies a smear. Over eons, the skin becomes peppered with tiny glassy spots and micro craters, like lunar soil in miniature. That glass can be slick. It can also seal pores. If the pores are sealed, gas looking for a path chooses the cracks instead. That's why activity on a weathered traveller is patchy. Not because the interior is stingy, but because the plumbing is complicated by scar tissue. Cold does not sleep while this is happening. In the deep dark, frost migrates on scales of inches. A molecule leaves one face, hops through vacuum, and sticks to a colder face in shadow. Do that long enough and you build hoarfrost in some hollows and strip others bare. When 3i Atlas rotates under our sun for the first time in a while, those hordes wake differently. Hoarfrost breathes readily, then collapses and crusts. Bare zones resist, then crack and erupt. The result is a skin that behaves like a quilt, square by square, with seams that matter. Electricity leaves its fingerprints too. Sunlight and plasma bathe small bodies and charge their surfaces. Fines, fluffy, electrostatically touchy motes can levitate and creep, moving from rough highlands to smooth ponds where the field lines and terrain coax them to settle. Over long flights between stars, this dust migration can blanket low spots with ultra-fine powder. When the traveller finally warms, those powder ponds release clouds of tiny grains that scatter light like fog, while the bare, hardened ridges cough heavier grit that trails close. Look at the tail of 3i Atlas on different nights, and you can see these neighbourhoods take turns speaking. One night fog, one night gravel. Sometimes both layered so cleanly you can read the edge where they meet. Radiation doesn't just darken, it cooks. Exposed ices change personality. Water that once held small molecules in its cages can reorganize and set those guests free. Carbon-rich films, organics born of endless tiny insults, coat mineral grains into something like soot that hates to reflect blue light. That's why a weathered surface usually looks redder and dimmer than fresh interior. It also explains a favourite cometary magic trick, a sudden bluing of the inner coma, when a fracture reveals fresh ice and glassy grains that haven't been browned by the cosmos yet. 3i Atlas performs that trick in miniature. After a burst, colour leans cleaner, then drifts back toward the baked look as sunlight lays a day's worth of patina down on the newborn skin. Strength lives at odds with itself under such treatment. The outer millimetres can become tougher to erode by steady breezes of gas, sealed, sintered, resin-coated. But that same shell is brittle. Thermal cycles, morning to afternoon, approach to recession, make it expand and contract. The shell cannot stretch. It crazes with micro cracks. Each crack is a future vent, a hinge, a zipper. When 3i Atlas warms quickly, because it is moving quickly, those cycles run on fast forward. You can diagnose the fatigue by the way the object prefers to exhale in pulses rather than in sighs, painting the tail with ribs instead of drapery. The interstellar medium is not uniform, and that matters. If the traveller spent time passing through a dense cloud, colder, dustier, richer in simple gases, its skin would have accreted an extra film, a frosting of nitrogen or carbon monoxide nestled among grains, a haze of tiny interstellar dust glued on by thin water layers. Later, in clearer space, that frosting could remain as a stubborn layer, buried just deep enough to ignore weak warmth, but ready to flash when sunlight finally digs in. Episodes where 3i Atlas acts too alive for its distance, then goes quiet again, carry exactly that accent. pockets of super-volatile memories the object gathered on the road. Spin writes whether the way wind writes dunes. If 3i Atlas tumbles, or even just rotates with a decent tilt, some latitudes will bake and others will shiver. Long seasons, measured not in months but in degrees of angle, grow their own crusts. The summer side cooks organics into a stronger varnish, tightens pores, and leaves vents that act like whistles. The winter side stores pressure under a weaker lid. Eventually a seam connects the two and you hear the result as a burst that makes observers look twice at their graphs. This is why a single body can seem inconsistent. It isn't changing its nature, it's taking turns showing us faces, seasoned differently by time. Polarized light gives away texture built by weather. Shine the sun at a rough micro-pitted surface, and the scattered light becomes preferentially lined up, polarized, by that roughness. When observers measure 3i Atlas at different angles and find polarization stronger than smooth models would predict, they are not catching a mood. They are catching scars. Combine that with color, and you can tell whether you are seeing fresh facets flashing or the steady smolder of a rind. On nights after a crack, polarization may dip as glassy interior dominates. Days later, as a new film grows, it climbs again. What about the interior glue? Weathering can turn a fluffy aggregate into something that behaves for a while like a single piece. Icy grains grow necks, organics act like resin, wicking into pores and curing under radiation. This raises the spin rate a body can tolerate before it starts to shed, until a crack undermines the support, or until a jet torques the mass into a wobble that concentrates stress. Then the apparent strength vanishes in a moment. The signatures are soft but real, a light curve that suddenly changes shape, a baseline brightness that climbs and never quite returns, a tail spine that thickens with heavy grains even though the gas did not roar. 3i Atlas plays out exactly those notes, hinting at a shell that can carry load most days and unlace on the day it cannot. Weathering even scripts how gas and dust divorce. In a young, clean surface, water and carbon dioxide drag fine particles with them faithfully, spreading a fan whose brightness fades with distance in a textbook way. In a crusted, sintered surface, gas can escape through hairline cracks too narrow to carry grains. The coma then becomes gas-rich and dust-poor close in, while solids arrive late, expelled only when a chip breaks or a plate lifts. That inversion, gas speaking first, dust following, pops up in 3i Atlas as short-lived blue cores that evolve into richer, redder veils hours later. The order of operations is a clue to the size of the pores and the thickness of the rind. Think too about all the little resets. When a fragment the size of a pebble breaks from a wall and floats free, it carries within it a miniature version of the same history, a weathered skin over fresher bed. For a few hours or days, that clod acts like a tiny comet, bleeding gas from its sides and dust from its tips. A swarm of such clods can temporarily change the coma's texture without changing the parent's main vents at all. It's an underappreciated way the past writes the present. The shell makes crumbs, the crumbs write the light. The light fools you into thinking the big engine has changed when it's the fallout doing the talking. If you lay all these processes on a table, you can start reading diagnostics without a single equation. A redder, darker look that only resets after an outburst. That's a rind with fresh exposures in patches. Polarization that spikes with phase angle and then softens after a burst. Rough skin giving way to glacier interior and re-hardened a few days later. A tail that alternates between spines and gores. Gravel from armoured ridges one night, fluff from ponded fines the next. A light curve whose amplitude shrinks even as activity continues. Facets being sanded smooth by fallback dust, or new mantling evening out the silhouette. 3i Atlas keeps handing us these checklists, and every time we tick the boxes, we're not just describing behavior, we're diagnosing history. Weather is not always erosion, sometimes it is growth. Photons carve and cure, tiny impacts compact and glaze, frost migrates and paints. The net is a skin that gets denser and more selective. It lets some gases through, keeps others prisoner until the temperature or the stress hits a threshold. That is why 3i Atlas can breathe carbon monoxide far from the sun, then clamp down, then gush water suddenly later, then quiet into dust only fits when thermal stress does the lifting and gas sneaks away unseen. The rulebook is not broken, it is layered, pages written at different times, read together by the sun in a single breath. The long road also changes the core's conversation with light. A heavily processed exterior absorbs more heat and re-radiates it differently than a clean, icy crust would. Thermal inertia rises or falls depending on porosity and bonding. That shifts the daily rhythm. Afternoon peaks can arrive late. Midnight outgassing can happen as stored heat ekes down into pores. On a slow returning comet, this evens out into seasons we can watch over months. On 3i Atlas, speed compresses the rehearsal into days, so the weather we attribute to interstellar time shows itself in fast motion in our week-long films. There is poetry in how little of this we have to assume to make sense of what we see. The tail's ribs are timestamps of vents locked behind scar tissue. The color's swing is the toggle between varnish and glass. The polarization's rise and fall is the fingertip reading a rough wall, then a fresh cut, then a wall again. The dust's refusal to behave is the courtroom where fines, fluff, pebbles and plates argue about who gets carried, who settles, and who pretends to be fog. 3i Atlas is not being perverse. It is being honest about having lived outside for a very long time. Every once in a while, a night arrives when the object looks too clean. The inner halo sharpens, the light curve tidies, the tail's silk replaces its barcodes. That is a gift, a patch of authentic interior stitched over by bygone winters has been torn open wide enough that for a turn or two, we are watching a traveller, as it might have been before the beach did its work. Those windows do not last. Sunlight closes them by baking a new film. Dust closes them by falling back and plastering the wound. But even a brief look is enough to anchor in reality the story the scars have been telling all along. So when we talk about interstellar weathering, we're not reciting a list of exotic effects. We're describing why a single body can carry contradictions without being contradictory. We're explaining how 3i Atlas can be both resilient and fragile, both bright and dull, both loud and shy, sometimes in the same night. We're acknowledging that outside the neat loops of our family, there is a beach where everything is always being worn and remade, and that the beauty of catching a traveller mid-stride is that you can still see the sanding marks if you know where to look. There's a certain kind of mischief in the data that makes observers lean back from the screen and say, very quietly, what if it's not just one? The fragment hypothesis lives in that pause. It doesn't begin with a dramatic photograph of a broken jewel. It begins with small betrayals. A light curve that loses its confidence. A coma that develops a kink where smoothness should reign. A tail that forks as if two hands are holding the same veil and tugging in slightly different directions. With 3i Atlas, those betrayals line up just enough to invite a long, careful look at the possibility that we're watching not a single traveller, but a family. Pieces that either broke long before we met them, or are beginning to part company under our sun. Imagine the interior first. Not a steel ball, but a city of voids. Porous ice, dust, and organics nested together like the crumb of a fresh loaf. Over eons between stars, radiation hardens the crust while leaving the inside fragile. When sunlight finally warms the surface, the hard shell resists at first. Pressure builds underneath as volatiles try to leave through clogged pores. Somewhere, usually at a seam between two different layers or in a neck where two lobes meet, the stress concentrates. A crack opens. Gas, long delayed, escapes like breath held too long. Most days that relief is enough. A plate lifts, a fan erupts, the shell slumps, and the traveller keeps going. But every so often the crack is a zipper. It races along a hidden fault, and what had been one becomes two. There are gentler ways to split too. Spin can be a quiet assassin. Jets act like uneven thrusters, stealing or donating angular momentum depending on where they are and when they blow. Over days or weeks, a slightly off-center push can turn a dignified turn into a wobble, and a wobble into a faster spin around a new axis. A loose, gravelly body can tolerate only so much of that. Past a certain point, the minimal gravity that holds pebbles and boulders in a cuddle loses the argument, and a clump detaches. Not an explosion, a shrug. The piece drifts away at walking speed, then at running speed, then at nothing like speed at all once you remember the scale, just enough to separate over days, not minutes. Heat contributes in a more sly fashion. As 3I Atlas rotates, some regions cycle through freeze and thaw with a cruelty that rock and ice don't forgive. Microcracks multiply. Pore networks that once meandered gently become highways. The load-bearing struts in the crust weaken. The next outburst doesn't just vent, it undermines. A ledge gives, a bulge slumps, a seam that had been asleep since another star was young wakes to its purpose. The traveller sheds not dust, but architecture. If fragmentation is in play, the sky leaves fingerprints. The first and most democratic is a persistent brightening that refuses to drift back to the old baseline even after the fireworks calm. That stubborn offset can mean a new steady source of light, maybe a secondary piece large enough to glow in its own right, too tight to resolve but close enough to thicken the core's halo. Stack nights and compare, and you find that what you thought was weather is actually company. The coma's shape is a sharper witness. A single nucleus with a rotating jet often draws a corkscrew or a fan whose symmetry you can predict from spin and sunlight. Add a companion and the geometry complicates. You begin to see overlapping fans with slightly different axes, a faint spine that seems to lean away from the main body's tail, as if answering to a different breath. A wedge whose brightness pulses with a rhythm offset from the primaries. In long, sensitive exposures, the isophotes, the imaginary contour lines of equal brightness, develop corners and shoulders where they should have been smooth. Those corners are the signature of two light sources tracing their own soft halos inside one larger veil. Sometimes the tail itself stops pretending. A forking down the backbone, a split that persists instead of smoothing out, says that heavy grains are departing from slightly different addresses. That's hard to do without two distinct vents widely separated on the nucleus. It's much easier to get if there are two nuclei, each laying down its own gravel road along nearly the same path. The spacing between the forks grows with time. Trace them backward and they meet close to the moment the mischief began. Colour and polarization sharpen the diagnosis. If a fresh piece splits off and exposes glacier interior, the inner coma can skew a little bluer for a night, while the newborn skin sparkles with small, clean grains. Polarization can dip, then climb again as that new surface is quickly dirtied by sunlight and fallout. If the companion is shedding finer dust than the parent, the combined halo gets a whisper of that difference. So slight you'd miss it in a single frame, so stubborn that, once seen across a sequence, it refuses to be noise. Combine those hints with timing, and you sketch a story, a crack, a breath, a piece set adrift, and two slightly different wardrobes, dressing two slightly different bodies. Light curves carry a more cryptic clue, a rhythm that develops a hitch. Before fragmentation, the peaks and troughs of brightness line up with rotation and with the on-off schedules of the main jets. After, you may see beats, two close tempos interfering. One peak arrives a few minutes early, another a few minutes late, and the pattern never quite repeats across multiple nights. It's not that the main body forgot how to spin. It's that a second nearby clock has joined the conversation, adding its own fainter rise and fall and spoiling the clean repetition. If the companion is small, the effect is subtle. If it's sizable, the composite curve looks like a duet. Astrometry, the unromantic art of pinning down a dot's position, chimes in too. When a coma is dominated by one nucleus, the centre of light sits close to the centre of mass, and the dot follows a prediction with small, steady errors you can model with gentle pushes from jets. Add a companion and the centre of light can wander as the relative brightness of the pair changes. On nights when the secondary flares, the centroid creeps toward it. On quiet nights, it slides back. Those small, consistent residuals, tiny offsets from where the calculations say the dot should be, are less dramatic than a photograph of two cores, but they're often the first proof you can trust. There's a temptation to blame illusions. An anti-tail lined up by geometry can masquerade as a second source. A narrow straight jet can mimic a spine drawn by a companion. A background star smeared by tracking can play at being a knot in the coma. That's why the fragment hypothesis is always, at first, a reluctant whisper. You try to kill it with every trick you know, different filters, different measuring circles, positive and negative image stacks to scrub out stars, time sequences that watch structures drift and rule out chance alignments. If the second source stays put relative to the primary while everything else slides by, if the fork grows with the cadence a separation would predict, if the rhythm keeps its extra beat after the moon shifts phase or an instrument changes hands, the whisper becomes a statement. Suppose we grant the premise: 3I Atlas has shed or is shedding. Then we can ask what kind of split we're seeing. Is it a flake? A sheet of crust that broke free and will erode into invisibility over a few days while adding a faint, stubborn brightness to the core? Is it a boulder? A compact piece that will carve its own small jet for a week before it dims beyond reach? Is it a true secondary nucleus, an object big enough to persist for months, marching a few thousand kilometers behind, writing its own mini coma and tail? Each class leaves a different trail in the data. Flakes change the inner slope of brightness and then vanish. Boulders draw thin, short-lived streaks that travel a little off the main spine. Real secondaries hold their place in the co-moving frame and keep their halo even as geometry changes. Origins matter. A contact binary, a two-lobed body joined at a neck, fails along the neck when torqued, a clean, emotional break that often produces two uneven pieces and a brief, furious burst as trapped gas gets a shortcut to freedom. A rubble pile gives birth more messily, shedding clumps from rims and pits as spin and heat pry at weak points. You get a family of crumbs rather than a single child. A hard, monolithic shard, rare but not impossible, can fracture along internal flaws like a pane of stained glass, producing angular fragments that flash facets and twist their polarization in ways soft rubble cannot. You won't see the crack itself, but you'll see its style in the weeks after. There are deeper time versions of this story too. It's possible 3I Atlas didn't start as one. In another system, under another sun, a larger parent may have been broken by a collision or by repeated tides near a massive planet, seeding multiple shards onto very similar escape tracks. Over ages, those siblings would drift apart until, by the time they reached our neighborhood, they'd be separated by more sky than any one search field can cover in a night. In that scenario, fragment hypothesis means co-moving clan, and the observational test is different. Not a forked tail or a dual halo, but a second faint interstellar visitor spotted along a parallel path some nights or weeks apart. We have to keep that door open in our thinking, because the cosmos often prefers families to singles when it comes to debris. If a fragment is present now, catchable in the same frame, its relative motion is a slow ballet. In the co-moving view, where you digitally hold 3i Atlas still, an authentic companion will creep in one direction night by night, separating by a little more each time. Its coma will brighten and fade with its own weather, not in lockstep with the primaries. The tail structures near it will point the same general sunward-anti-sunward way, but will have slightly different textures because the companion's vents and size differ. The key word is slightly. The art is in seeing those small differences and proving they repeat. Fragmentation also rewrites the way outgassing pushes the path. Jets on the primary and on a companion can point different ways at different times, yanking the pair with misaligned tugs. If you try to fit all the astrometric points with one set of gentle pushes, you'll get a worse fit than you used to. Give the model permission to include a second source, even if you can't resolve it, and the fit improves. It's a dry satisfaction, the kind only a plot of residuals can offer, but in this business, neat residuals are poetry. You can hear echoes of past split comets in all of this, even if the details belong to our own system and not to an interstellar visitor. Strings of pearls that marched along the same arc, nuclei that became families overnight and then dwindled over a season into faint, coasting cinders, wide fans that turned into forked brooms. We know those signatures in principle. The novelty here is the accent. 3i Atlas brings interstellar weathering, an outer rind forged in a different radiation bath, and a pantry of ices arranged by another disk's temperature profile. That changes how and where it breaks, and how loudly. There's a human rhythm to the chase. You get a suspicious night. You bite your tongue. You ask for confirmation from a different hemisphere. Someone with a big mirror and steady air sends a stack that shows the same kink you saw. You whisper louder. A week later, the fork is unmistakable, the centroid wander is undeniable, and the light curve will not keep a single beat no matter how you bribe it. The whisper becomes a note to the world. There might be 2 or 3, and then the flood of independent checks either washes the idea away or builds it into a fact you can't ignore. Why does it matter, beyond the thrill? Because fragments are samples with labels. A split along a neck says the body may have been 2 to begin with, formed as a pair that later hugged and fused. A shed crust says the skin was stiff and the interior under pressure. A slow carving from a rim says spin won the argument with gravity and cohesion. Each style of failure reaches back to conditions in the nursery. Grain sizes, ice mixtures, the pace at which small bodies grew, the violence of their neighbourhood. For an interstellar traveller, those inferences are the only way we'll ever touch its birthplace. Pragmatically, fragments can make or mar the rest of the observing campaign. A companion can be bright enough to feed spectra with lines that confuse the primaries, or faint enough to be a nuisance in photometry without being a prize on its own. Tracking rates may need adjusting to hold both in a slit. Wide fields become precious. The way we share fields and cadence across the network changes. One team sticks to the core. Another watches for the creeper at a set offset each night. A third builds deep stacks to pull out ribs and spines that betray the new source. The choreography becomes more elaborate because the science demands it and because the clock doesn't stop. All the while, the possibility remains that we are catching the traveller mid-sentence. Today's hint of a companion might be tomorrow's confirmed double, or it might be a flake that glowed and died. The fork might widen into a proud V, or it might soften as dust settles and geometry shifts. That uncertainty isn't a flaw, it's the drama. Fragmentation is not a single event stamped on a calendar. It's a process, a negotiation between heat, spin, structure and time, played out on a stage so small and far that light is our only messenger. So we keep reading that light the way a beachcomber reads the tide line. Are there two sets of footprints or one? Do the ripples overlap or diverge? Does the driftwood point in one wind or two? Night by night, 3i Atlas answers with small, consistent choices. A centroid that walks, a curve that beats against itself, a spine that splits, a colour that briefly freshens and then settles. Put those choices together, and the fragment hypothesis stops being a ghost story. It becomes a working description of a body honest enough to admit that it's held together by patience and dust, and that sometimes patience runs out, and dust remembers how to fall apart. Gravity gets the headlines for the obvious, pulling everything toward the sun and curving paths into neat arcs. But its best work is quieter. It whispers rather than shouts. It slips small biases into motion, stretches one side of a body a hair more than the other, and lets those hairs add up. Watch 3i Atlas long enough and you start to see those whispers. They live in the tiny tilts of the tail, in the way dust seems to hesitate near the core before committing to the wind, in the slow drift of a spin axis that nobody pushed with a hand. Call them tides, torques, nudges, focuses, gravity's little tricks, and they turn a simple flyby into a layered, living problem. Begin with the simplest trick. The field isn't flat. The sun pulls harder on the near side of 3i Atlas than on the far side. That difference, tiny but relentless, is a tide. On a big world, tides move oceans. On a small traveller, they move stress. As the object sweeps inward, the gradient steepens, and those stresses prowl through the crust looking for seams. A crack that would have stayed quiet at a gentler pull suddenly grows, and gas that was trapped under a scab finds daylight. We see it not as a dramatic tear, but as timing. A jet that wakes earlier in the day than it did last week. A burst that arrives closer to the sun than models with no stretching would have placed it. The tide didn't create the vent, but it opened the door a half turn sooner. The same gradient tilts the way dust leaves. Picture a grain that has just been lofted. It is only a few meters from home, but already the sun tugs on it a touch less than it tugs on the nucleus. That touch matters. The grain's path bows outward as it falls behind, and the collection of many such grains paints the tail with a subtle spine and soft wings. When radiation pressure joins the game, the fine stuff goes wide and bright, while the heavier bits drag close. But gravity still sketches the underlying geometry, the slow curve that the sunlight merely exaggerates. On some nights with 3i Atlas, you can read the two hands separately, the solar pull drawing a patient arc, the light's push feathering it. Spin doesn't get a pass from gravity either. An elongated body in a changing field feels a gentle torque, like a long key twisting as it falls. It's the same reason a satellite above Earth wants to point its heavy end down. 3i Atlas is no satellite, and sunlight's breath does most of the nightly steering, but the gravity gradient torque is there, slow and stubborn. Over days it can nudge the spin axis, slightly changing which surface patches see noon, which vents face morning, and which jets get to act like thrusters. You won't hear a click. You'll see the effect as a light curve that keeps the same beat but leans its emphasis a different way, or as a corkscrew plume whose pitch changes by a few degrees over a week. Tides don't stop at the surface. They nibble at the internal architecture too. If 3I Atlas is really a handshake between lumps, a contact pair joined at a narrow neck, then the neck bears the gradient's mischief. The near lobe and the far lobe are pulled just differently enough that the narrow bridge experiences the tiniest repeated flex. On a single pass, that flex won't snap stone, but if the bridge is more foamed crust than solid rock, and if sunlight has already laced it with micro cracks, the tide can be the last small thing that starts a zipper. When that happens, we don't see a cartoon split. We see a new component glow faintly beside the old one. The coma's isophotes grow corners, and the tail's spine fork into two lines that slowly separate night by night. Planets add their own sly refinements. You don't need a close brush with Jupiter to feel Jupiter. Its hill of gravity bulges so far that even a respectful pass gathers a measurable deflection, a thumb on the path that doesn't change the one-way nature of the trip, but does tilt the outbound aim by more than a purist would like. That tilt is enough to alter how long the tail looks, how the phase angle evolves, when the strongest backscatter flashes happen, even whether a brief anti-tail lines up with Earth's viewpoint. The numbers live on someone's whiteboard. The feeling lives in the way an observing plan written last week suddenly wants a different filter tonight because a predicted geometry slid by an hour. Those planetary nudges also write themselves into the dust. Heavy grains laid down along the path, gravel that barely listens to sunlight, form a faint, persistent trail. A far pull from a giant planet can fatten or thin that trail by changing which slices of the path intersect our line of sight. When 3I Atlas is favourably placed, the trail looks like a slim steel wire behind the comet. When a nudge changes the alignment, the wire loosens into a ribbon. No new dust needed. Gravity, working through perspective, remixes last week's breadcrumbs into a new picture. Closer to home, even Earth is a co-author under the right alignment. The planet's tug is usually too small to matter unless the pass is near, but near doesn't have to mean dramatic. A shallow shift in apparent motion, a perspective acceleration, sneaks in during our own nightly rotation. For a slow comet, you can ignore it and fix it in the morning. For a quick traveller like 3I Atlas, those small shifts change where the slit should point, how long the exposure can run before the nucleus steps out, and whether a faint rib in the tail will be blurred into the background or caught cleanly. Gravity here isn't bending the object's destiny, it's bending our choreography. There is a trick at the tiniest scale that gravity plays with fragments. A pebble that peels off the surface leaves with almost the same motion as the parent. For a while, the nucleus's weak pull can almost keep it as a moonlet. That almost is the hill neighbourhood of a small body, a bubble of space where its tiny gravity competes with the sun's far stronger tug. Inside that bubble, fragments can hover, loop, or re-impact. Catch 3I Atlas on a night when such a piece is lingering, and the inner coma looks asymmetric in a way that rotation alone can't explain. A steady, bright patch in one quadrant, a notch in another, faint spokes that come and go with a period slightly off from the main body's spin because the companion is tracing its own tiny ellipse. Days later, the bubble empties, the sun wins, and the small moonlet joins the trail, a new seed for the dust spine. Tides also teach by subtraction. In a steady field, a rotating jet paints a clean corkscrew. In a field that's changing quickly, as at perihelion, the corkscrew stretches on the sunward side and tightens on the anti-sunward side. The pattern looks lopsided, even if the vent keeps perfect time. With 3I Atlas, the lopsidedness is sometimes the only warning you get that the traveller is crossing from a gentle gradient into a steeper one. No formulas required. You can see it in the pictures as a spring pulled longer on one end, wound tighter on the other. Further out, gravity draws lanes in the solar system that small bodies prefer. They are not visible highways, but they act like them. Resonances with the giant planets make some longitudes of space more influential than others. An interstellar visitor is not captured by those patterns, but it still passes through their neighborhoods and picks up a whisper of their order. The whisper shows up as a timing bias. The window when the tail is best placed for our view drifts just so. The span of nights when gas lines are least contaminated by air glow happens earlier or later than a naive sun-only model guessed. People call this planning. It is, underneath, gravity's city map asserting itself. Dust again. Sunlight sorts grains by how easily it can push them, but gravity keeps the ledger honest. Big grains that sunlight barely moves stay loyal to the path. Small grains betray it at once. In between lies a class that debates, and the debate writes beautiful features. Thin ribs at angles, striations that run parallel for a while then diverge. Delicate fans that lift away from the spine and then fade. These are not random, they are synchronies. Families of grains born together and then shaped by the tug of war between the sun's pull and the sun's push. When 3i Atlas paints several at once, you can read the history backwards. This rib was born when the tide was steeper, that feather when it was kinder, this whole panel when a distant nudge changed the line of sight and made a week-old sheet suddenly stand out. Even the nucleus's shape gives gravity a place to work quietly. A very lumpy mass distribution means the down direction isn't neatly toward the geometric center everywhere. Gas that seeps through pore networks follows pressure gradients, but dust lofted at low speed listens to local gravity right away. It either returns to the slopes it launched from, mantling them, or escapes for good. The effect is a kind of gravitational gardening. Over time, flat basins collect fines and grow smoother, ridges shed them. Then, when a burst comes, those basins feed fog, and those ridges feed gravel. To an observer watching 3i Atlas night after night, it looks like personality. This region always gives me silk, that region always throws sparks. Underneath the personality is a map of tiny down vectors, guiding where grains land and where they don't. Planetary tides can also tweak the way a tail points in subtle ways by curving the paths of very slow grains after they leave the nucleus. No planet is close enough to yank a plume like a kite string, but on a night when Earth lies under the tail's sheet, the planet's field can deflect the drifting gravel by a barely measurable angle, and that angle can shift the brightness ridge a little to one side. Most nights nobody would notice. On the right night, with deep stacks and patient subtraction, the ridge's lean looks a degree off. The usual suspects, phase angle, changing grain sizes, get questioned. Then someone checks the geometry and shrugs. Gravity again, showing off only because the view was perfect. On the outbound leg, after closest approach to the sun, gravity keeps a few last cards. The sun's pull takes longer to relax than our intuition expects, so 3i Atlas continues to move quickly even as it fades. That speed keeps the gradient in play, and the gradient keeps working on any fresh cracks opened at perihelion. If the body was going to fail along a seam, the most likely time is just after the deepest tide, when stresses start to ebb, but internal pressure and spin have their say. When observers see a delayed fork in the spine or a late-blooming secondary halo, it's not a contradiction. It's consistent with a tide that primed the fracture and a few extra rotations that finished the job. There's a planning trick born from all this. Use gravity to make the sky help. When the field will stretch a rotating plume into a readable asymmetry, schedule more color work to tell dust from gas. when a distant planetary nudge will lengthen the time a faint antitail is favourably aligned, commit more aperture to deep stacks that week. When the object is entering a steeper gradient, favour cadence over depth because short-lived stress releases are likelier. 3i Atlas rewards that strategy. Treat gravity as a partner, and the data feel coherent rather than capricious. None of these tricks need big theatrics. A path that won't close is the headline. The way that path is minutely retuned by gradients and glancing pulls is the story you only hear if you stay for the whole performance. The pleasures are small but deep. A centroid that walks a hair's breadth on nights when a nearby fragment flares. A corkscrew that looks a touch lopsided near perihelion and then relaxes. A spine that leans a degree one way this week and a degree the other way next week, because a giant planet's far hand turned our view by an angle you could cover with a fingernail at arm's length. Add them up and you get a portrait of a traveller that answers to the galaxy's big architecture in miniature, carrying those answers in its dust, its spin, its cracks, and its changing tail. Gravity, in other words, is not just the chorus humming under the melody of sunlight and vents. It is the arranger. It decides which instruments we hear when, which notes get stretched, which harmony sits slightly off to make the phrase interesting. 3i Atlas is a good listener. It sings as it must, fast, unbound, temperamental. But the phrasing, the rubato, the little hesitations and accelerations, those are gravities. If you learn to hear them, you stop being surprised when a fan sharpens here, a spine splits there, a jet leans when you thought it would march straight. You expect the tricks, and in expecting them, you see further into what the traveller is made of and how it chooses to move through the light we lend it. The first thing a simulation gives you is courage. You draw a shape, assign a spin, tuck some ices under a crust, set the path of the sun across that surface, and watch the virtual traveller breathe. The brightness rises and falls. A tail blooms and bends. You tweak a knob and the curve responds. It feels like conversation. Then you compare your tidy plot to the unruly light of 3i Atlas, and the courage thins. The peaks arrive early. The colour swing goes the wrong way. A neat corkscrew you were proud of turns to mush when viewed from the exact angle Earth had that night. You add one more parameter, then 5, then a dozen, and the fit gets better on Tuesday and worse on Thursday. This is the place where simulations tap out. Not at the edge of computing power, but at the point where reality refuses to be uniquely explained by the things you already know how to describe. Start with the friendliest models, the ones built for local comets that return and give you years to learn their habits. Those models assume a nucleus you can summarize simply: a rough shape, a single spin axis, a rotation period that doesn't wander much. They spread activity across latitude bands or pin it to a handful of vents. They assume the same family of ices everywhere, just more or less exposed. They use dust that comes in a few sizes with well-behaved optical properties. Feed them 3i Atlas and they do fine for a night or two. They catch the slow swell as sunlight strengthens. They sketch a conventional fan. They even mimic a modest outburst if you poke a vent a bit harder. But the moment the object flips mood, dust without gas here, gas without dust there, a light curve that looks like two beats arguing, they start losing the thread. You can make them follow, but you have to keep telling them what already happened, and a model that can only explain the past is a diary, not a forecast. The core trouble is degeneracy. 10 different interiors can draw the same light curve. 5 dust-sized distributions can copy the same tail. A dozen vent maps will all produce a rib at the angle you observed if you allow the spin phase and the jet strength to drift. You nudge one assumption and 3 other knobs must move to keep the picture plausible. That's not error, It's the math of incomplete information. An inverse problem, the art of inferring cause from effect, has many answers when the effect is a faint smear thousands of kilometers wide, and the cause is happening on cliffs smaller than a city block. Then there are thresholds, the enemies of smooth models. A crack stays quiet for days and then runs in minutes. Poor ice reorganizes and dumps its guests all at once. A jet that seems steady on average is actually turning on and off with a strobe you can't resolve, and the tail integrates that flicker into a misleadingly calm ribbon. Classic thermophysical codes prefer gently graded responses, a little more heat, a little more gas. 3i Atlas acts like a machine with sticking valves. You can fake this by adding switches to your code. If pressure exceeds X, open gate Y. But every switch is a guess about where the hinges are, and the more guesses you add, the less your result is a prediction, and the more it is a sketch polished to resemble the data you already saw. Assumptions about shape are another trap. Many pipelines begin with spheres or squat potatoes because they're fast and good enough. But a bilobed body throws light like a lighthouse. 2 lobes, 2 sets of facets, a neck that can vent like a whistle. Add a slow wobble, and the geometry of sunlight across that sculpture changes by the hour. You can upgrade your model to a lumpy mesh and solve for temperatures and vents face by face, and you will feel responsible for having done it. Then you will notice that 3 different lumpy meshes, all reasonable, produce the same family of curves once you let the unknowns roam. You have turned the problem into a contest of priors, which shapes you allow, which vent patterns you think are natural, which porosities you deem realistic. The result reflects your choices as much as the skies. Dust physics promises salvation and then runs you in circles. We know how sunlight pushes on grains of different sizes and textures. We know how fast gas can loft them from different terrains. We can calculate how their brightness should fall with distance from the nucleus under steady flow. Put all that together, and you can generate delicate striae, spines, fans, and antitails at will. But the coma of 3i Atlas is not a steady faucet. It's a choir of dripping taps. Each episode imprints its own thread, and threads overlap. You can match any one rib by choosing the right burst time and grain mix. Matching 3 ribs at once while also matching the coma's overall slope and colour and the polarization at 2 phase angles is where the edges fray. Every success on one metric erodes the fit somewhere else, a reminder that the actual dust is a spectrum of sizes and structures changing in time, in a way you did not tell your code to allow. Non-gravitational forces are the quiet saboteurs of trajectory fits. The cookbook way is to add a gentle shove, aligned with the sun object line, maybe with a small sideways component, scaled to activity that rises and falls with distance. For returning comets, this works beautifully. For 3i Atlas, it works until it doesn't. Activity is patchy, and the net thrust can tilt with rotation. A simple shove becomes a sequence of micro pushes, whose average can look like a wobble in the path for a few nights before averaging out later. You can include time variable thrust in your integrator, but you don't know its phase ahead of time, so you are always tuning after the fact, and the best fit acceleration can end up absorbing errors in your centroid measurements, in your tracking, and in the wind of the solar plasma you didn't model directly. Your pretty residuals hide sins. Even the light itself will not sit for the portrait you want to paint. Reflectance models, those tidy recipes that say how bright a surface looks at a given sun observer angle, work for many asteroids and for quiescent comet nuclei. But a coma is not a surface, it is a volume of floating mirrors and smoke. The brightness you record at a pixel is a sum of sunlight scattered once, twice, and sometimes again. A pixel on one night includes grains from multiple events. Grains evolve as they drift. You can use more sophisticated scattering theories and still fall short because the thing you need most, the actual distribution of grain shapes and coatings, changes in hours and you don't know it. In practice, you end up using an average scatter law and then adding fudge factors so the inner coma's slope and the outer tail's width don't contradict each other too loudly. It's honest work. It isn't truth. What about brute force? Throw a swarm of models at the wall, thousands, millions, span the space of spins, vents, dust mixes, and thermal properties, and keep the ones that survive your tests. This helps. It teaches you which conclusions are robust, that some supervolatile must be near the surface to explain early activity, that some regions must be inert to preserve the observed lulls, that the rotation state cannot be a simple, stable turn if the period wandered the way it did. But brute force also exposes a sobering fact. Many wildly different internal worlds can cast very similar shadows on our detectors. Your posterior, the crowd of models that fit, doesn't collapse to a single story. It remains a village. You can rank villagers by plausibility, but you cannot crown a monarch. Data gaps do as much damage as physics. The best clues 3i Atlas offers sometimes live in hours we miss. A cloud deck, a bright moon, a mount under maintenance, a bad cable. A single lost night can erase the hook in a light curve that would have told you whether the wobble sped up before or after the burst. A missing colour sequence can keep you from knowing whether a jump was gas-led or dust-led. Your simulation, desperate for continuity, smooths over the absence because physics hates discontinuities. But discontinuities are the point. A model that can only interpolate gracefully will never confess that the sky sometimes writes in steps. Noise is not evenly noisy. The background is uglier near twilight when geometry is best. Star trails cut through your measuring circle when you track the target, and your subtraction is never perfect. A faint rib in the tail might be real, or it might be the echo of a star that your mask didn't fully erase. Simulations rarely ingest the actual mess of your images. They ingest cleaned profiles and curves, already distilled. By the time you compare, you are matching a model, not to the raw world. You can fix this. Forward model all the way to fake images and reduce them as if they were real. But that demands time you never have during a transient, and when you do it after the fact, the transient has moved on. Even when everything is working, the pieces don't line up on the same clock. Thermal models want minutes for the surface and hours for the subsurface. Spin evolution wants days. Trajectory fits want weeks. Dust tails remember for months. Try to make one simulation that honors all those clocks, and you will find yourself cheating each in turn. Coarsening the grid here, smoothing a spike there, grouping grain sizes into buckets so the computer doesn't choke. The cheating is necessary. The cheating matters. It is often where your neat agreement with Wednesday's image sows the seed of Friday's failure. There's a deeper philosophical limit hiding in plain sight. A simulation is a story told in advance, and a good story needs a cast list. With 3i Atlas, the cast includes actors we have never seen on stage. Unfamiliar mixtures of ices, interstellar crusts with strange mechanical properties, vents that open and close according to stresses laid down by a radiation field our local comets did not endure. We bring the props we own and improvise, but sometimes improvisation just means we keep renaming the same character to cover new lines. Unknown unknowns are not poetic. They are the difference between a model that explains and a model that predicts. None of this means we stop modelling. It means we change how we use models. Instead of demanding that a code reproduce every wiggle, we weaponize disagreement. Where do the residuals cluster? Which nights are stubborn? Do the failures correlate with a particular phase angle, with a pole orientation you assumed, with a colour that hints at chemistry you didn't include. Those are not embarrassments, they are instructions. A model that can't match the early bluing without a shallow layer of a super volatile tells you something physical whether or not you like the number it spits out for the abundance. A dust simulation that only draws the observed barcodes when you let bursts last less than an hour tells you something about vent scale, even if the rest of the coma is wrong. We can also let the sky steer the code in real time. Data assimilation, feeding last night's images back into today's forecast, feels messy, but it's honest about the pace of a fast visitor. You adjust the vent map when a rib appears. You retune the spin when peaks slip. You publish the next night guess with error bars wide enough to fit a truck, because the point isn't bravado. It's setting traps for the object. Specific signatures that would falsify today's best story, so tomorrow's story can be better. This is not capitulation. It is the difference between stubbornness and learning, and we can design the observations to break the worst degeneracies instead of trying to brute force them later. If a light curve and a tail image can both be explained by two very different dust mixes, add polarization at a second angle. If gas and dust are entangled in the core, grab simultaneous color instead of alternating nights. If vents and spin are blending into a single wiggle, increase cadence for a short run rather than take deeper images an hour apart. The right extra piece of data is often simpler than a fancier code. When simulations tap out, what remains is a kind of disciplined humility. You stop expecting a single model of 3i Atlas and start keeping a short list of models that survive contact with the facts and disagree with one another in ways that matter. You let the list guide the next night rather than your ego. You learn to love partial victories, a tail angle nailed within a degree while the inner coma sulks, a period drift captured while the amplitude misbehaves, a colour swing predicted while the absolute brightness balks. Each partial adds a tile to the mosaic, and the mosaic is the thing, not the tile. The secret mercy is that this is how nature wants to be approached. The traveller does not owe us a clean syllabus. It offers clues wrapped in noise and timing, wrapped in geometry, wrapped in chemistry we can only infer. A simulation is a spotlight and a mirror. It shows where we are staring and what we are assuming. When 3i Atlas shrugs off our neatest lights, it isn't being coy. It's telling us to move the lamp, to admit which props are cardboard, to trade a universal theory for a set of mechanisms that can be mixed and matched as the sky demands. That trade is where understanding lives. Speculation begins where data thins. It's not a flaw in science. It's the engine that idles while we assemble the next instrument, the next night, the next idea. With 3i Atlas, speculation came in waves, each one shaped by the questions our measurements couldn't quite nail down. If a brightness surge had no matching perfume of gas, someone would whisper about unfamiliar ices that evaporate invisibly. If a tail sharpened into a blade and then dissolved, someone else would imagine vents with geometry like no cliff we'd yet mapped. And looming over it all was the perennial electrifying question that visits every interstellar stranger. Could any part of this behaviour be engineered rather than natural? It's a powerful thought, not because it is likely, but because it forces clarity. It makes you say aloud what exactly would count as evidence, and what would only be a story we told ourselves on a sleepy dawn. The honest path starts with baselines. Nature is inventive. We've watched local comets impersonate engines before, jets that switch on with clockwork precision, fragments that fly in formation, dust sheets that look like sails. So the first discipline is to exhaust the natural catalogue. Can patchy layered ices do this? Could a crust with interstellar sintering create pores that act like valves, producing on-off behaviour without any technology hiding behind it? Could sunlight alone pushing on a cloud of ultra-fluffy dust, make a non-gravitational nudge that mimics propulsion? If the answer is yes, plausibly, the speculation engine downshifts. The second discipline is to ask for signatures that don't care about our preferences. An engineered object would likely advertise with control, a repeatable phase-locked acceleration that holds its direction even when the spin wanders, a thermal pattern that looks more like waste heat than like frost, sublimating in patches, a spectrum with lines that belong to alloys rather than minerals, or the stubborn absence of any gas where gas must appear for a natural explanation to work. 3 independent, disinterested methods are the gold standard. Photometry alone won't do it. Astrometry alone won't do it. Spectroscopy alone won't do it. But if timing, position and colour all insist on the same improbable story, then the burden shifts. A third discipline is falsifiability. If you can't imagine a measurement that would make you abandon the alluring idea, you aren't doing science, you're daydreaming. For 3i Atlas, falsifiers were easy to articulate and hard to collect. A clear detection of familiar volatiles at just the right moments would sink an engine notion. A measured correlation between spin phase and brightness that matched a lumpy, tumbling body would gut a sail hypothesis. Conversely, a persistent push aligned with no natural jet geometry, holding steady across weeks while vents flickered and failed, would challenge us to reach beyond the usual shelves. Speculation also needs an accountant. Selection effects love to impersonate mysteries. We are likelier to notice an interstellar visitor that is active, fast and bright against a star-poor background. We are likelier to publish the weird nights and less likely to shout about the plain ones. We are likelier to target filters that historically paid off, and in doing so, we risk repeating our own biases back to ourselves. The accountant's job is to tally the misses, the cloudy nights, the null detections, and fold them into the story so that strange has a denominator. With 3i Atlas, that ledger kept reminding us that some of the most puzzling episodes lived at awkward angles or in the stingiest twilight, prime times for illusions, while several of the boring nights fell under pristine skies. There is also the humane rule: never let "we don't know" degrade into therefore extraordinary. The middle ground is where most truths live. For 3i Atlas, the middle ground was rich. Unknown ices from an alien nursery, interstellar weathering that made crusts with unfamiliar mechanics, plumbing that opened and shut with thresholds we haven't parameterized well. Those are wild enough. They honor our lack of complete understanding without importing intent where none is needed. They also keep our imagination sharp for the day we really do see a signature that refuses to sit anywhere in nature's catalogue. Still, speculation is not the enemy. It's a tool we use to design better tests. If someone posits a reflective sheet that catches sunlight like a sail, you can answer with polarization campaigns and phase angle sweeps that would spot unusually strong, angle-dependent scattering. If someone proposes exotic ices that leave no obvious lines, you can schedule deep, simultaneous color measurements across bands where those ices would nudge the continuum slope, even if they kept quiet in emission. If the chatter suggests a controlled trajectory, you can tighten the astrometry with a global, high-cadence network to catch any small, steady bias. The point isn't to rule in the exciting idea. It's to build a test that would ruin it efficiently if it's only a story. Through all this, 3i Atlas proved to be a generous teacher. It gave us natural puzzles, layered, moody, fast, that forced the speculative questions to become specific. It made us say, if engineered, then we must see X. If natural, then Y should follow within hours. That sharpening changed the nightly plans. More cadence here, more colour there, extra attention to geometry everywhere. By the end, the speculation engine had done its job. It didn't deliver a dramatic reveal. It delivered better science, tighter definitions, cleaner tests, and a community quicker to share failures. That's how you keep wonder alive without letting it pick your pockets. You ask for signatures, you count your biases, you design your ruinous tests, and you let 3i Atlas be as strange as it needs to be without assigning it a purpose it never claimed. A stranger is a mirror. The way we react to it shows us our habits. The way it behaves shows us what we take for granted about home. 3i Atlas, by refusing to be a tidy version of any single local comet, turned into a diagnostic for our own solar system's past. Start with ejection. Our models say young planetary systems are messy, their giant planets restless, their outer belts thick with debris. When those giants migrate, they fling ice rocks into deep cold storage and eject others into interstellar space. If a visitor like 3i Atlas arrives wearing ices that wake early, carrying a crust hardened by a radiation field different from ours, it confirms that ejection isn't a rare catastrophe. It's the normal price of building planets. Our Oort cloud likely exists because our giants did the same rude work. Seeing a traveller built by another set of giants tells us ours were not unique. Then consider chemistry as a compass. The inventory of gases and dust in 3i Atlas, when it chose to show them, wasn't wildly alien, but the sequencing was. Early breath far from the sun, then an awkward thresholdy awakening of water, episodes of dust with little gas, then gas with little dust, colour swings that hinted at fresh glass one night and baked organics the next. That sequencing is a fingerprint of formation temperature and later processing. It implies that wherever this body grew, there were cold zones cold enough to trap delicate molecules near the surface, and later seasons harsh enough to armour those stores under a thin rind. If you transpose that onto our own early disk, you get a clearer picture of the gradients our comets must have experienced. Pockets where nitrogen could stick, shelves where carbon monoxide pooled, edges where organics were cooked and recooked into the dark stuff that reddens surfaces. 3i Atlas lets us ask whether our own long-period comets bear the same layer cake, and, if not, whether our young sun's neighbourhood was warmer, brighter, or simply noisier in a different way. Spin and structure reflect us too. A body that wobbles easily and changes its rotation under modest sunlight implies a granular interior, a rubble architecture glued by frost and resin-like organics. That's the same story we tell for many local comets and some small asteroids. The difference is seasoning. Interstellar weathering may make the outer millimeters stiffer and more brittle than our comet's skins. If 3i Atlas sheds in lacy plates, while some locals crumble like stale bread, the contrast says something about the time our bodies spent inside the sun's magnetic shield, where the radiation chemistry is gentler. In that sense, the visitor is a control experiment. What does a small, icy body look like when it grows up outside our heliosphere's protection? On larger scales, the visitor refracts our theories of migration. If you collect enough interstellar travellers and sort their chemistries and dust behaviours into families, you're building a census of other systems mixing histories. Lots of Borisov-like water-forward comets would tell us that cold, volatile-rich belts are common and stable. A surplus of 3i Atlas-style, thresholdy, layered breathers would say outer belts get baked and shaken before ejection more than we assumed. A surprise prevalence of Oumuamua-like coma-shy shards would imply a robust population of tough, desiccated fragments, maybe the end state of many planetesimals after violent histories. Every bin in that census is a mirror held up to our own early chaos. If we're unusual, we'll see it. If we're average, we'll see that too. Even our observational blind spots are exposed. The nights when 3i Atlas was loudest in dust but quiet in gas are exactly the nights our pipelines are most likely to misclassify a thing if we only chase classic gas lines. The episodes when a tails barcode emerged only after careful stacking teach us how many local comets might have pulsed without anyone noticing because we didn't look with enough cadence. The way the inner coma's slope changed when vents clogged or unclogged reminds us that some of our taxonomies are really snapshots of mood, not fixed traits. That humility loops back. When we classify our own comets, we are now more likely to ask whether a label was earned by physics or by the luck of our schedule. There's a cultural mirror too. 3i Atlas showed how quickly our community can move when the guest is clearly interstellar. We coordinated longitudes, opened data, traded raw frames fast, and asked sharper questions sooner. Why wait for a visitor to behave well to be so generous? The mirror asks, could we treat faint locals with the same urgency, especially those poorly placed or badly behaved? The answer matters because those locals are the fossils of our own past. The techniques we honed on the stranger, shift and stack rituals, global cadence, polarization sprints, work just as well at home. Finally, the visitor casts light on the subtle topic of survivability. How many small bodies endure the combination of tides, spin torques, and thermal stress near a star before they fracture beyond recognition? 3i Atlas, by keeping itself barely in one piece long enough to trace its single pass, suggests a threshold between coherence and carving that depends sensitively on crust, porosity, and jet geography. That threshold, transferred to early Earth-crossing comets, touches stories about water delivery, organics, and the tempo of bombardment. In a roundabout way, a brief, moody visitor from far away ends up informing how our oceans and atmospheres might have been salted. So, yes, a mirror. In the silhouette of 3i Atlas, we see more than a traveller. We see the outline of our own formative storms, the biases in our instruments, the holes in our records, the habits in our planning, and the flexibility we didn't know we had. The stranger doesn't tell us who we are. It gives us a clean surface to hold our assumptions against until we can, finally, tell ourselves. From the outside, astronomy looks like a single act. A dome opens, a photo is taken, a mystery appears. Inside, it's carpentry. Measure, subtract, align, cross-check. Watching 3i Atlas turn the shop into a chorus, it begins with patrol. Wide-field surveys sweep the sky in overlapping tiles night after night, looking for anything that moves or changes. Software subtracts last night from tonight, flags the not-quite stars, and chains the survivors into short arcs. Most are junk, satellites, glints, ghosts. A few are real movers. 3i Atlas started as one of those low-confidence maybes that got promoted because another telescope far away saw the same hop. That promotion flipped switches everywhere. Non-sidereal tracking engaged, cadence tightened, filters chosen with purpose, alert notes sent to anyone who can see the same patch of sky within hours. Astrometry, pinning the traveller's position, comes first because everything else depends on knowing where to point next. Tracking the object makes the stars smear. Letting the stars stay sharp makes the object smear. For a fast mover, you let the stars suffer. Then you model their trails so the bright scratches don't drag your centroid off target. You calibrate against catalogues that know where every useful star lives. You measure the dot's center not once but many times in short exposures, so a gust of seeing or a jolt in the drive can't fool you. Those positions flow to a central brain that refines the path and spits back a forecast for the next observatory in the relay. Photometry, measuring brightness, rides on those coordinates. You can measure the core alone with a tight aperture to hear the nucleus's heartbeat, or you can widen the circle to include the inner coma and listen for weather. With 3-eye atlas, teams did both, often in the same minute, a tight cup for timing, a wide cup for context. They corrected for air itself, the air mass that steals blue light at low angles, the thin cloud that drifts through like a grey thought, by watching field stars and building a reference curve that says how the night is misbehaving. They recorded not just numbers but the shape of the curve, humps, shelves, corners. Those shapes kept becoming characters in the story. Colour and polarimetry give the light a voice. Colour is simple in principle. Measure how bright the coma is through different filters, compare, and infer which particles or gases are at work. In practice, it's a dance. You want the measurements as simultaneous as possible, so the object doesn't change under your feet. For a fast visitor, that means 2 instruments side by side or a rapid filter wheel and quick exposures. Polarimetry is fussier. You rotate a polarizer or split the light into polarized beams and measure how much of the glare lines up in one direction. Rough dust, fresh dust, old dust. They polarize light differently. On nights when 3-eye atlas looked the same in brightness, its polarization shifted, telling us the surface had flipped a page. Spectroscopy is the delicate surgery. You feed a slice of coma light through a narrow slit, spread it into a rainbow, and hunt for the faint signatures of gas, tiny hills on that rainbow that betray molecules. The slit must ride the moving dot precisely. The exposure must be short enough that the traveller doesn't step out, long enough to catch enough photons to matter. Sky emission lines and air glow lay their scribbles across your canvas. You subtract them with care. Often you walk the slit across the coma, on the nucleus, then off to one side, to see what changes. A detection one night and silence the next can be physics or weather or both, so the rule is simple. Never trust one spectrum. Ask for a chorus from multiple telescopes under different skies. Imaging becomes a craft of subtraction. Stars are beautiful and in the way. You align frames on the moving object, smear the stars into trails, and then subtract a model of those trails to reveal faint structures. Ribs, spines, corkscrews, anti-tails. You stack dozens, sometimes hundreds, of short exposures to build signal in the tail without letting its delicate filigree blur. With 3-eye atlas, shift and stack tactics let small telescopes punch above their weight, slice the night into many little sips, and add them along the predicted motion, so that a rib invisible in any single sip becomes visible in the sum. Cadence is the secret ingredient. Depth is prestige, big mirrors, long exposures, but cadence is truth for a moody traveller. A jet that turns on for 40 minutes will never appear in hour-separated snapshots. So the plan changes. A burst of quick frames to catch the beat, a pause for calibration, another burst, traded among facilities around the world so the night never truly ends. In group chats and shared dashboards, one team posts a surge, another confirms, a third reports a colour tilt, a fourth points a spectrograph, and, if the sky cooperates, snags a pale line where there was only continuum before. The relay is literal. The baton is a link with timestamps. Pre-covery is archaeology. Once the path is good enough, you search old images of that part of the sky, nights or weeks before discovery, to see if the traveller left a faint footprint nobody noticed. Finding it extends the arc, tightens the trajectory, and sometimes reveals a quieter mood, a dustless night, a coma-free point, a hint of early gas where you wouldn't expect any. For 3-eye atlas, every pre-covery frame was a way to cut through selection bias and say, it wasn't always this loud, or it was whispering long before we had the microphone. Amateurs are not the chorus's audience, they're a section in it. Sharp backyard rigs with good tracking, short exposures and fearless cadence can watch the same feature for hours while larger facilities juggle cues. An amateur image that shows a rib appearing midway through a night can be the clue a spectroscopist needs to set the slit on the right quadrant of the coma. A photometric light curve from a modest scope can catch the precise moment a peak shifted, proving a spin change that bigger mirrors, committed elsewhere, missed. The best campaigns treat these contributions not as nice extras, but as threads in the main fabric. Calibration is housekeeping, and housekeeping is science. Bias frames and flats, images of darkness and of uniform light, remove the camera's fingerprints from every measurement. Without them, gentle features in the tail can be illusions, and subtle color shifts can be artifacts of vignetting. With 3i Atlas, teams swapped flats between nights and even between sites to check whether a rib at a certain angle was in the sky or in the optics. They binned pixels when the seeing was poor to preserve signal to noise, then unbinned when the air steadied. They annotated everything: wind, humidity, guiding errors, the moon's distance, because tomorrow's confusion might be solved by tonight's scribble. Scheduling turns into social engineering. A target racing across constellations demands a different kind of generosity from observatories. Someone gives up a half hour near dawn so another can catch the traveller at the one angle that matters for polarization. A queue manager reshuffles to let a spectrum run short, and often instead of long and once. An instrument scientist rushes a software tweak so non-sidereal rates can be fed precisely instead of by hand. 3i Atlas pulled favours everywhere and paid them back in learning. It taught us that agility is not chaos when the goal is shared. Space telescopes, when they can play, add a layer we can't get from the ground. Wavelengths blocked by air, stability no mountain can match, and the two stare with the sun without the sky drowning the view. But even there, the choreography is touchy. Pointing limits, bright object constraints, and the need to justify precious time force us to predict behaviour days ahead. A visitor that changes moods in hours asks us to stick our necks out, schedule a mid-infrared look right when we expect fresh dust sizes to separate, or a near-infrared spectrum when a supervolatile might speak. Sometimes we guess wrong. The trick is to make even the misses useful by pairing them with simultaneous ground sequences that explain why the sky declined the invitation. Behind the scenes, pipelines hum. Code catches the obvious, flags the odd, posts the quick-look results, and invites humans to argue. Automations announce when the path has shifted beyond some threshold. Slack channels light up with plots. Someone overlays last night's isophotes on tonight's and circles a new corner. Someone else checks whether the angle agrees with a rotating jet model. A third runs a dust dynamics toy and says the spacing matches a 40-minute burst. No single image tells the story emerges from the braid. And then there's restraint. Not every kink means a fragment. Not every drift means a sail. The culture that grew around 3i Atlas prized fast sharing and slow claiming. Provisional language wasn't weakness, it was a safety rail that let us speak while the data was still hot. We see a fork. Possible secondary source needs confirmation. Colour tilt toward blue for an hour. Candidates include fresh ice, geometry or calibration, working to discriminate. This discipline wasn't performative. It saved time. It kept us from chasing clever ghosts while the real signatures, the ones that would matter a year from now, were happening a degree to the left. In the end, how we actually watch is a stack of unglamorous decisions that make wonder possible. Short exposures over long, cadence over depth when the mood is quick, global handoffs instead of local heroics, flats and biases, even when you're tired. Honest errors bars, even when the plot looks prettier without them. 3i Atlas rewarded exactly that kind of care. It was a fast guest with a complicated wardrobe, and the only way to keep up was to make the act of looking as alive and adaptable as the thing we were looking at. When something fast and faint slices through our sky, the only way to keep up is to turn Earth into one long turning observatory. Handovers happen not just between telescopes, but between people and habits. A mountain in the west works to exhaustion under a setting crescent. An island in the ocean takes the baton before the data's even cooled on the first team's disks. A desert in the south lines up the same target with different filters, because colour is a second language that brightness can't speak. Schedulers bend their rigid cues, slipping in short bursts where hour-long blocks once ruled. Someone on a chilly summit calls out coordinates to a colleague sipping coffee in daylight, and a third person, far away, stitches raw frames into a quick-look image so the world can decide in minutes whether to pivot or press on. There are quiet heroes no one sees. The engineer who patches a tracking software bug so non-sidereal rates stop jittering. The student who recalibrates flats at 3 a.m. so a faint rib in the tail is real sky and not a smudge in the optics. The amateur who wakes early, runs a rapid shift and stack from a backyard rig, and posts the first confirmation that the spine is split. Coordination isn't only geography, it's grammar. You agree on what a burst means in minutes, how big an aperture to use for the core versus the inner coma, how to report a colour tilt without implying a gas that the spectrum didn't actually show. You keep a live sheet where positions, brightness bumps, and oddities go in real time, colour-coded by confidence, so the next site knows whether to chase a rumour or a result. You don't hoard frames, you push them, warts and all, because a dusty traveller changes in hours, and the perfect reduction that arrives tomorrow can't steer tonight. In the background, small automations hum, scripts that watch for a deviation from last night's path and send a nudge to every subscribed telescope, dashboards that plot the light curve as it grows, so a wobble seen in Chile can be checked in Spain while the object is still high. Weather is the wild colleague you never fire. Thin cloud snips a planned spectrum into pieces. Sahara dust drifts across a mirror and stains the sky with a tan haze. The moon rolls in and pours silver over your fields, so only the bold features survive. You work around it. Cadence beats depth when the air is dirty. Wide fields beat narrow ones when the path crosses star-rich lanes. If a northern site is socked in, a southern team shifts to a broader filter to catch the same story in a different register. Coordination looks from outside like improvisation. Inside, it's choreography practiced on quieter nights so that when a guest like 3i Atlas arrives, the steps feel inevitable. The most surprising allies are classrooms and living rooms. A high school club runs time series photometry for 3 hours and catches the exact moment the light curve's peak slips, a tiny proof the spin is changing. A retired engineer with a sharp Newtonian telescope images near dawn for a week and, by sheer persistence, documents a faint anti-tail that bigger mirrors missed while chasing spectra. A regional observatory drops a public watch party, turns the cameras to work, and provides a clean run of polarization angles that let the dust's texture speak. Credit passes along with the baton. A thumbnail on the group chat with a first name and a location becomes part of the record that a decade from now will still be the way we know this visitor. The road is rougher than the highlight reel. Power blips in the middle of a perfect sequence. A dome balks when ice locks a gear. Customs holds a calibration lamp for a week. A target of opportunity clashes with a carefully scheduled planetary program. and people negotiate in good faith because the sky won't wait. Coordination is logistics in service of wonder, moving equipment, time and trust so that a fast, unbound light can be read like a continuous sentence as it crosses a page the size of Earth. What do we chase next? Patterns first. We hunt for rhythms that repeat across interstellar visitors, the telltale timing of early breath before water wakes, the way a light curve's beat wanders under sunlight's torque, the spacing of ribs in the tail that betrays the length of events fit. If 3i Atlas writes a barcode of short episodes, 30, 40, 60 minutes, we measure those gaps night after night to see whether the planet's pull, the phase angle, or the object's spin geometry changes the punctuation. A single outburst is a surprise. A cadence of outbursts is a mechanism. We chase composition with gentler questions. Deep colour done at speed, taken simultaneously rather than alternating filters, can whisper whether a jump was gas-led or dust-led, even when the spectrum is too thin to sing. Polarization at two angles on the same night can tell whether a fresh surface has been exposed. A glacier, cleaner scatter that fades as fallback dust paints the wound. Mid-infrared glows, where the heat of grains reveals their sizes, let us test whether a burst favoured fluff or gravel, and whether that preference changes with distance from the sun. We ask the sky to repeat itself enough times that the guesswork becomes a plot you can point to. We look for geometry that breaks degeneracy. Occultations, moments when the traveller steals a star's light for a heartbeat, can outline the core's silhouette and, if we are absurdly lucky, reveal a fragment lurking nearby. A few chords across a slender shadow turn rotations from inference into measurement. Close to the sun in the sky, when the tail's forward scattered glare is loudest, we push for risky twilight sequences that can separate the tiniest grains from the rest. On outbound legs, when the object is fainter but more stable, we run long stacks to pull the heavy-grained spine from the background and read a week of history laid down like a thin wire. Not every answer lives at an eyepiece. We will bake and blast analogues in laboratories, mixtures of ices and dusts, salted with simple organics, under cold light and particle showers that mimic interstellar time, then warm them fast to watch crusts lift, pores unclog, and trapped gases flee. The textures we grow on those samples will tune our expectations, how easily a sintered, radiation-cooked rind cracks, how quickly a newly exposed patch browns into a dimmer scatterer, how a clathrate's sudden unlatching might look when all you can see is a light curve. In drop towers and parabolic flights, we'll watch granular comet soils tumble and settle under near weightlessness, so that our mental picture of a rubble interior comes with numbers rather than metaphors. We will also prepare for the next guest before it knocks. Survey cameras will be taught to flag fast, faint movers not just as dots on the run, but as dots likely to be interstellar by the way their early arcs refuse to bend like locals. Alert pipes will package not just coordinates but likely non-sidereal rates, useful filter choices, and a first-cut mood estimate. Dust forward, gas quiet, or gas forward, dust shy. Networks will practice follow-the-sun drills on artificial targets so that the human timing, the sleepy minutes where messages get missed, shrinks. And somewhere, quietly, engineers will keep sketching a ready-to-launch chaser, a small spacecraft that can sprint from a parking orbit and meet a future interstellar passerby for a brief hello, because there are answers that only a close pass can grant. We'll keep lists of signatures that, if seen together, would change our minds. A persistent, phase-independent acceleration that refuses to line up with any plausible vent geometry. A thermal pattern that looks more like a radiator than a rind. a spectrum flat where nature never is. Not because we expect them, but because we should have tests ready the day nature surprises us beyond its usual inventiveness. The point of what next is not to wish for exotic outcomes. It is to be ready to separate the merely unusual from the truly new. And then, after the long chase and the quick adjustments and the nights that went wrong and right in equal measure, we stand somewhere quiet and look back at the line we've traced together. The deeper we looked, the stranger 3-eye atlas became, not because it hid its face, but because each clearer view revealed more seams, more thresholds, more ways simple forces can braid into complicated lives. A point of light became a mood became a map became a mirror we could hold up to our own system and ask better questions about how worlds are made and unmade. Strangeness, it turns out, is not the opposite of understanding. It's the companion that keeps understanding honest. When a traveller refuses to be one thing, we stop pretending our categories are the sky and start treating them as tools. We learn to love partial answers and to stack them carefully until they carry weight. We learn to make our curiosity social because no single dome can hold a fast guest long enough to make sense of it. We learn again that humility is not a pose but a method. 3-eye atlas will go on, unbothered by our metaphors. It will carry its patched crust and quilted vents and quiet inner glue into distances where our light grows too thin to touch it. But it leaves us richer, with better reflexes, clearer tests, sharper eyes for barcodes in dust and hesitations in brightness, and a renewed appetite for the next knock at the door. The universe did not promise to be simple. It promised to be legible if we learned its alphabets and read them together. Tonight we added a few letters. Before you go, tell me what surprised you most about 3-eye atlas, the moody dust, the restless spin, or the idea that interstellar weather can harden a crust until it breaks like lace. If this journey through the strange kept you curious, tap subscribe and join me for the next deep dive. Your support genuinely helps me make more of these. Drop a comment with the one question you still have. Share this with a friend who loves cosmic mysteries. And if you want another rabbit hole right now, queue up one of the videos waiting on the end screen. See you in the next one.